So
Basically,
I think we should like go over those units again though.
you found them easy.
Yeah, I found them pretty easy.
Yeah, the thing is, when you actually started, so this was your first interaction with these topics,
Yep.
and then we climbed the ladder up. Unit 1 till 21. This is the current we'll be doing today. So 20 units and some practice at home, some practice at school, some practice in class. You did pretty well on the weekends and in your vacations. So you will definitely find them easy.
Okay.
If there is something specific, we can definitely recheck that. And there are some topics on which the questions would be lengthy and some would be pretty small in
Okay.
length and marks as well, such as this vectors and transformation. These would be lengthy questions. We are currently on 21. And if I just go back, you would have seen that cumulative frequency, the question might stretch to 2 pages.
Okay.
And then quadratic formula, that would require a bit of practice.
With sine, cosine, and tangents as well.
Yeah, trigonometry.
Yeah. The first 4 units are basically like an overview of like everything.
Yes,
The rest
yes.
of all the units.
Mostly arithmetics.
Yeah. And then afterwards it starts going into more detail.
Yes.
Okay.
Okay, this is ratio, rate, and proportion. So a quick recap in ratio in chapter 5, we did this. Like if you could look at this first question, 8 by 10 could be written as 4 by 5. Or I can also write it as 16 ratio 20. Any doubt in this? We had a practice question like write 5 or 4 similar fractions. If I have just 1 ratio 2, I could write 2, 4, 3, 6, 4, 8, 5, 10.
Yeah, no
It
issues.
was 1 and the other is double.
Yep.
Rate is the comparison between two quantities. Normally, we had time in the other axis to compare, and proportion is out of that. When two quantities are in direct proportion, they increase or decrease at the same rate. For example, we are preparing sandwiches. So if number of bread would increase, definitely the amount of butter would increase in the same proportion. Working with ratios, we know we can multiply and divide the numbers, the fractions with the same numbers. A ratio could also be written as fraction. 1 ratio 25 could be written as 1 over 25, and 5 ratio 3 could be written as 5 by 3. Just the order would matter. First one is the numerator, second is the denominator. Writing ratios in simplest form is just cancelling out 20 and 20 and 100. He just cancelled out those zeros first, but if I know the table, I could just say 21 times and 25 times is 100. Now 1 by 5 could not be further simplified. Worked example, Sanjita mixes 8 liters of white paint with 3 liters of red paint to get pink paint. What is the ratio of a red paint to white paint? Now red paint is already 3 and white is already 8, 3 ratio 8. What paint to total amount of paint is the mixture? White paint. Now white was in the question, mixes 8 liters of white paint, so that's 8, and total amount is 8 liters of white and 3 liters of red,
So
so
11.
that's 11. And the order would matter. If someone writes 11 ratio 8, that's wrong.
It's the way the question phrases it.
Yes. Now red paint to total is 3 ratio 11. Just consider that we were talking about some sort of medicine, and the doctor prescribes that take 1 spoon of the white bottle and 2 spoon for the red bottle, and someone just remembers 1:2 and forgets which one it was, so that will definitely create a chaos. So a ratio would matter, order would matter.
Yes. Okay.
And also if we are talking about increasing or decreasing, so definitely if I'm talking about temperature, that what was the temperature, I'm not telling you the exact temperature, but I'm saying 2:3. So that would mean yesterday it was 2 and today it's hotter. And if I say 3:2, you would just understand that today the temperature is lesser than it was yesterday. To, to make concrete, you mix cement, sand, and gravel in the ratio 1:2:4. Now, the first one is obviously cement, the second is sand, and the last one is gravel. What is the ratio of the cement to gravel?
2 to
Is
4.
cement and gravel. Cement is the first one.
Oh, so 1 to 4.
What is the ratio of sand to gravel?
So that is 2 to 4.
Correct. 2:4. May I write 1:2?
Yep. Simplified.
Simplified. So, what is the ratio of gravel to the total amount of concrete?
4 to 1.
4 is gravel, and what
Oh,
is total amount?
total. This is total amount of concrete.
Yeah,
Okay, so that would be
next
6.
is known as
Next 7.
that is
This is 7.
1 plus 2 plus 4.
Yes.
What
Mhm.
fraction of concrete is a cement? So that is actually 1 out of total 7. Practice exercise. Write each of the following as a ratio: 9 men to 9 women.
9 to 1 to 1 simplified.
Uh, that's correct. Okay, if you're doing this way, that's again correct.
When we answer these questions, they prefer the simplified version, right?
We would show the complete working in exam. I'll try to do that the same here as well.
Okay.
I was just like focused on less space.
Yep.
1 liters to 5 liters.
So 1 to 5.
1 to 5. 25 minutes to 3 minutes.
So 25 to 3.
18 seconds out of every minute. 18 ratio, what should I write?
360.
S-
3,600.
Every minute, not hour.
But that's seconds.
Yeah, 1 minute is 60 seconds, and 1 hour is 300 and
Oh, yes, yes, yes.
600.
Yeah. So 18 to 60.
Now we could simplify these two. I'm dividing both of them with 6. I get 10 and 3. 15 cent out of every $1.
So
So
50 to 100.
very good. Now can you cancel them out?
We can make it 3 to 20.
3 to 20 is correct. 2 milliliters out of every centimeter. So this is 2 millimeter
2
and
to
this is 1
1.
centimeter. First
Can
we
we
need
drop
to
it
make
to
them same unit.
Okay.
2 millimeter would be how many centimeters in millimeters?
10.
10 millimeters. And now the simplest ratio,
1
1
to
ratio 5. When we have the same units in a ratio, we do not write units because now it is 1:5. We know that. So it could be 1 millimeter to 5 millimeter, or it could be 1 kilometer to 5 kilometers.
So we have to write ratio when it's different, basically.
Yeah, I had to write 2 millimeter ratio 1 centimeter because I couldn't write one alone.
Yep.
Either I would have directly converted it and just not written it. So I could write 2:10.
Okay.
Anytime we do this, the units must be same. For example, uh, D part, we wrote 18:60 and we didn't write 18 seconds. I could have written 18 seconds ratio 1 minute. That's again true. 18:1 is not the answer, but we have also written the units with them. It creates no confusion. So then we change them into same units
But
and
we
then
also
set
have to
the
change
ratio.
it to the same units, right? So you
Yes.
can't just okay.
Ultimately, we have to write everything in same units and write the ratio without giving the units.
Okay, I see.
A packet of sweets contains 12 red and 5 yellow sweets. What is the ratio of red to yellow?
12 to 5.
12 to 5. Yellow to red,
5 to 12.
5 to 12. Look at these two rectangles, rectangle A, rectangle B. Express the following relationship as ratios. The length of rectangle A to length of rectangle B.
So that would be 8 to 3 to 12 to 4.
Now, 8 to 12 would be enough. We would consider the longer side as length and the shorter sides as width. And then
Oh,
8 to
okay.
12 could be simplified to 2:3.
Yes. Okay.
Width,
So that'd be 3 to 4.
3 to 4. Now be very careful when you do that in exam. Here he is not tricking anything. All the A's are written first and the diagram A is also on the left hand side. So careful when you do that. He's asking A to B or B to A. C part, perimeter of rectangle A to perimeter of rectangle B.
11 to 32.
11 to,
11 to 32.
if you're considering only these two, then you should consider only these two. 11 to 16.
Oh, sorry. So then it would be 22 to 32.
22 to 32. Now simplify.
11. Oh yeah. So 11 to 16.
So remember, when we are dealing with lengths, we actually knew this was 8, this was 3. So in case of perimeters, this is equal, like we just did it. Either you find out the whole perimeter or just include length and width, because that is just the double of that.
Okay.
So it would give same answers. Area of rectangle A to area of rectangle B.
24 to 48.
48.
So
Right.
then
Yeah.
that would be just 1 to 24.
1 to 2.
Oh yes, 1 to 2.
The table gives the mean life expectancy in years of some African animals: tortoise, parrot, elephant, gorilla, lion, giraffe. Find the ratio of life expectancies of giraffe to tortoise. Now it says giraffe first. So I'll write giraffe first and then tortoise and
So
then
1
what?
to 12.
12. Yeah. Lion and gorilla.
15 to 30. So 1 to 2.
Lion to tortoise.
15 to 120. So that can be 5 to 40.
you're dividing it with 3, 5 to 40. And what next?
And then it can be 1 to 8.
1 to 8. 1 to 8, yeah. Elephant to gorilla.
35 to 30. And that can be 7 to 6.
35 to 30. Yeah, nice. 7, 5, 7 times and 5, 6 times, right?
For part C, what is
Yeah.
an easy way to get from 15 to 120 to 1 to 8?
We can do that in direct form because 120 is divisible by 15.
Okay. And then that would just be 1 to 8. Okay.
Yeah, even if you have like 200 ratio 100, we can see through that this is 1 ratio 2, 2 ratio 1. But if you just choose to do it this way, that's not an issue at all.
But it takes more time.
Yeah, that definitely would. But uh, like I'm just telling that all the students are not equal. Maybe some are very good at mental math. So some might go through few cuttings and then get to the simpler answer.
Okay. So
Parent line.
pixel is 50 to 15. So that could be 5 to 3. I mean 10 to 3.
So 5 10 times and 5 3 times. Yes. Parrot to tortoise.
50 to 120. And it could be 5 to 12.
Okay, lengths. Without the table, what is the ratio of a millimeter to centimeter?
1 to 10.
1 to 10. Centimeter to meter?
1 to 100.
The reverse of it.
Oh, meter.
100 to 1.
1.
Meter to centimeter?
So 1 to 100.
1 to 100. Gram to kilogram?
1 to 1000.
1000 to 1.
Okay.
Liter to milliliter?
So that would be 1000 to 1 again.
We start with 1 because liter is a larger quantity, millimeter is smaller quantity. A minute to an hour?
So 1 to 60.
I think that's wrong.
But there's 60 minutes in an hour.
So 60 to 1.
So when it's less than, we have to start with the higher value.
See, this is minute and this is hour. 1 hour could be 60 minutes, but 1 minute cannot be 60 hours.
Because there's 60 minutes in an hour. Okay.
Yeah. Express the following as ratios in their simplest form. 25 liters to 50 liters.
25 to 50. So 5 to 10.
5 to 10, and then
It can also be 1 to 2.
1 to 2. So this is the simpler form. 5 to 10, he would deduct it. So it is 1 ratio 2. B part.
25 to 200.
25 cents to 200, right?
And then we can make it 5 to 40. And then 5 to 40, we can make it 1 to 8.
1 to 8. Now see, this is your practice. What would be 25 to 100?
1 to 4.
1 to 4. So straight away, 25 to 200 is actually double of that. So 1 to 8. That just depends on your practice. But it is correct either way. C part.
75.
Yes, 75 to
75 to 100.
Y 100. That's 2 meters.
Oh, 200. So
200.
75 to 200. And then we can divide by 25. So 3,
25 3 times and 25
8 times.
8 times. Correct. E part 15 millimeters to meters.
15 to 10,000.
That would be 1000.
From millimeter to centimeter.
See, 1 meter equals to 100 centimeters.
Yeah.
And for every centimeter, there are 10 millimeters.
So 1,000.
Yeah. Now we simplify.
3 to 200.
3, you're dividing with 5. So 3 to 200. F part.
2.5 to 50.
I think I missed this D part.
Oh, okay.
Let's try D first. This is 600 grams to 5 kilograms.
So 600 to 5,000.
5,000, right?
And then 6 to 50.
And then
And it can be 3 to 25.
3 to 25. E's been already done. Now F part.
2.5 to 50. And then that can also be,
We cannot just double it because I can see 2.5 doubling would eliminate the decimal. We could also multiply both of them with 10 and write 25 ratio 500. And we can also just double them and write 5 ratio 100. Getting it?
yeah. So that would be 1 to 20.
1 to 20. G part.
4 to 2.5.
See, 1 centimeter is equals to 10 millimeters.
So
So
4 to 50.
40 ratio 25.
We have to multiply the 4. Okay. And
Yeah.
then afterwards, it could be 8 to 5.
8 to 5. H part. 400 ml to 3 liters.
400 to 3,000.
Correct.
And then that could also be 4 to 30, which could simplify to 2 to 15.
Equivalent ratios. Now that is actually the repetition of chapter 5. So 1 ratio 4 could be written as x ratio 20. There are different ways to write it. If I just choose the first one, 1, and the second one is 4, and then write x by
Yeah.
20 in the same order, and I can cross multiply.
Yeah.
20 by 4 equals x. X is equals to 5. So 1 ratio 4 is equal to 5 ratio 20. So in the case, x is just 5. And the second one is 4 by 9 is equals to 24 by y. Cross multiply again. Y is equals to 24 into 9 by 4. 4 1 times, 4 6 times, and
54.
6 9 times is 54. Find the unknown values following equivalent ratios. Use whichever method you find easiest. The 2 ratio 3 and 6 ratio x. So what would be x?
9.
Correct. X 5, y 20.
24.
24 is correct. 6 by 5 is equals to y by 20. So y is equals to 24.
12 by 8 to 3 by y. So 12y equals to 15. Oh, no. 12y equals to 24. So that's just y equals to 2.
Y is equals to 2. D part.
27 by x, 9 to 2. And that could just be 6. X 6.
6, yes. I can also see that 9 to 27 is actually 3 times. So 2 to x would also be 3 times.
Okay.
If you could just see that 3 to 66, first to first. May I say this is 22 times?
Yes.
So 8 to x would also be 22 times. So x is equals to 8 into 22, which is 176. Now this is 13 times more.
So 5 times 13.
So 5 times 13 is
65.
65. X to 7, 25 to 5. So it's better to think this way. This is being increased 5 times.
35.
40 to 800.
So that would be by 20. So
Decreased 20 times.
40 decreased by 20.
No, 9 decreased by 20. See,
Okay.
40 by 9 is 800 by y. So if the numerator is, increased by 20. 40 is being increased 20 times, so 9 increases 20 times.
Oh, I
180.
thought you said decreases.
Yeah, I took it that way as well. That was increasing.
Okay. So 9, 20, 180.
I part.
So that is 200. And then 7 to 200 is
Yeah, 200 times.
1,400.
So this again 200 times
1,400.
1,400. J part. How many times?
15.
Yeah. So 7 into 15 is
105.
K part.
So that could just be 4. And then 5 divided by 4. So that could be 5 divided by 4. 1.2 continue. Like
1.25. 5 by 4 is 1.25. 6 by 1.5 was 4, and 5 by 4 is 1.25.
okay.
L part 1 by 6 ratio 1 by 3 and 2 ratio y. So if I just look at these ratios, this is being doubled. So this should be doubled as well. What do you say?
4.
Yeah. Use the equation cross multiplying fractions method to find the unknown values in the following equivalent ratios. Exactly the same we've been doing. Let's just try question number 3. Say
You,
whatever these.
you're gonna
Yes.
send question 2 for homework?
So, I'm just skipping to in order to find different type of questions.
Okay.
We just did 12 similar parts.
But could you send question 2 for homework?
Yeah, sure, I will share it. I'll
And
share the cheat sheet.
yeah, and more like these ones as well. Like the cross multiplication.
Sure.
Okay. Thank you.
Say whether these statements are true or false. If the statement is false, explain why it is false. The ratio 1 ratio 6 is the same as ratio 6 ratio 1. True or false?
It's false.
That is false. And the reason is
Because like you wouldn't be able to multiply
that's
one.
correct. Let put it into simpler words. May I just say the fraction is increasing 6 times and the second fraction is decreasing 6 times?
Yes.
Or we can just say the second number in the first ratio is larger. And in second, it is reverse. Now the ratio 1 ratio 6 is equivalent to 3 ratio 16. True or false?
It's true.
That's true.
Because on the first one, the number is increasing by 6, and the second one's also increasing by 6.
Increasing by 6, yes. That is one way. And second way, we could just simplify and show that the ratio simplifies to same 1 ratio 6.
Okay.
C part. The ratio 2015 can be expressed as 3:4. True or false?
False.
That's false. Because it could be simplified to 4:3. D part. If the ratio of the mother's age to her daughter's age is 8:1, and the daughter will be 9 when her mother is 48, is this true?
False.
That's right. This is false because if the mother would be 48, the daughter has to be 8 times less and she has to be 6, not 9. Try E part.
Correct. It's true.
That's correct. Right. And that is just true because 20 by 32 would simplify to 5 by. I just got a reply from Mr. Kashif. He's shared a screenshot that he sent an email. Maybe that went in your spam.
I'll
He
ask my mom. I'll ask my mom about it and see.
contacted on 14th of September. Maybe the email is in spam, so you could directly contact him. I've shared the number and email as well.
Okay. Because I don't have access to my mom's email, I'll just ask her to see her spam folder.
Yeah.
Okay. For question E, we can just write 20 over 32 equals to 5 over 8, right? Or do we have to write like a sentence of 20 over 32 simplifies to 5 over 8? Or do any more calculations?
That is always advisable to write one short sentence.
Okay.
It may appear like too much while we are doing this chapter, but in exam, this type of question, that's only one.
Yeah. Okay.
Okay.
How
Apply
many questions are in total in the exam?
in total. So basically, not much of a difference. And one more thing, my personal advice is, and if you already have a counselor, definitely he'll have more experience with other students as well. I would just say that if you go for A levels, keep all the subjects restricted to A levels. If you go for Edexcel, keep all of them to Edexcel. Keeping them one board and keeping one certificate of result makes less paperwork.
Yeah. Okay. Okay. So those 4 papers are for one subject, right?
Yes.
Okay.
In O levels, you have two papers for like mathematics, and for physics or chemistry, you will have three. One of the paper is alternative to practicals, and same goes for A levels. You have four papers of mathematics, but for physics or chemistry, you would have five. One additional paper is for the practicals.
Okay.
Yeah. So the exercise just continues, and I guess it keeps the same throughout the chapter, mostly the same. Okay. So number 4 says an alloy is a mixture of metals. Most of the gold used in jewelry is an alloy of pure gold and other metals, which are added to make the gold harder. Pure gold is 24 carats. So 18 karat gold is an alloy of gold and other metals in the ratio 18:6, which we can pretty much see that 24 carat, like all the ratios were gold, but now only 18. So remaining 6 are is something else. In other words, 18 by 24 parts pure gold and 6 by 24 other metals. A jeweler makes an 18 karat gold alloy using 3 grams of pure gold. What mass of other metal does she add? Now, 18 karat gold, she is using 3 grams of pure gold. I know 18 by 24 of the total is 3. Would you agree to this expression?
18 by 24 of the total times. What is the total?
Unknown.
Is it 24 the total?
Uh, Sorry, what mass of other metals? I actually went for total. He was asking other mass. So we could write that 24 ratio 18 is using 3 grams of gold and unknown gram of the remaining, and I should use 6 in this place. 6 ratio 18 and x ratio 3. Does that make sense? Because 18 was for gold, this was for other metals, and she used 3 grams of gold. And when we just cross multiply, I get x is equals to 1. So basically, if she's using 3 grams of pure gold, what mass of other metals she adds? She adds 1 gram of other metals to make the total ratio same.
So 18 carats of gold and then 3 grams of pure gold.
Now, see, you went to buy gold and you're
Yeah.
looking for 18 karat gold,
Yes.
but maybe you are buying 3 grams of it, maybe you are buying 300 grams of it, maybe you're buying 3 kgs of it.
Yep.
So the question was just that if the jeweler says that there is 3 gram of gold, you can reverse calculate it and you would know that there's 1 gram of other metals. The total mass would be 4 grams. Go through this first statement. A jeweler makes 18 karat gold using 3 gram of pure gold. So if gold is 3 and we know the ratio, so the remaining must be other. So that is 3 ratio x. And when you solve for it, you get x as 1 gram. Is it clear?
It's 18 to 6 and then it's 3 to x, which gives us 1. Okay.
Yes. B part says an 18 karat gold chain contains 4 grams of pure gold. 4 gram of pure gold. So may I say 18 ratio 6? This is gold ratio something else. So if we have 4 grams of pure gold, how much would be other metal?
24 divided by 18.
I'm getting, why are you using 24?
4 times 6.
Yeah, right. So that's 4 by 3, 1.33 continued. So that is 4 by 3 gram of other metals. What is the ratio of gold in other metals and 14 karat gold? See, pure gold was 24. So if it is 14 karat, how much ratios are remaining?
So
14
now it's
ratio.
total, right?
Yes, now to total. So how many are remaining?
10.
14 is gold
10.
and 10 remains. And we could simplify it to 7 ratio 5. So what is the ratio? 7 ratio 5.
And then D would be 3. I don't know. D would be 12.
The part, what is the ratio of gold to other metals? 9 gold is used, so 24 minus 9 is 15. See,
9,
24.
yeah. So 24 minus 9 is what's the remainder, and that gives us 15.
Yeah. Pure
Okay.
gold is 24 carats. So if 9 carat gold is there, remaining is impurity. Number 5. An alloy of 9 carat gold contains gold, copper, zinc, and silver in the ratio 9, 12.5, and 2.5. Express this ratio in the simplest form. 9, 12.5, and 2.5. Now, what I'm going to try is I'm going to divide all of these with the smallest number. Like
2.
divide all of these with 2.5. So 2.5 by 2.5 would be 1. 12.5 by 2.5 is 5. And 9 divided by 2.5 is, I'm getting decimals, 3.6.
We can just imagine this, like we can just multiply this by 10.
Yeah, that would have been simpler. Yes.
Then
36, 50, and 10.
when we do that, do we have to also divide it by?
Yeah. Go on, go on. We will end up with same answer. Whatever we do, we'll end up with same answer.
So when we divide it, like we have to divide it by 10 after we get 36, 15, 10?
Anything, no issues.
Okay.
You go with your method, like 90 and 125 and 25, you will end up with same answer. Still doing it?
Have we moved on to B?
Yeah, I was waiting you to confirm if you got the same answer.
Oh no, yeah, I did.
Okay. B part says, how much silver would you need if your alloy contains 6 gram of pure gold? See, the ratio is already there. How much silver will we need if we have 6 gram of pure gold? So we know the ratio. First one is for pure gold, second is copper and zinc, and the last one is for silver.
So
So I have
9.5 to 6 to X.
6 and I need this much. So I'm just going to copy gold and silver and leave 12.5. 9 gram of gold combines with 2.5 gram of silver. So 6 gram of gold will combine with X gram of silver.
So 15 divided by 9.
Yeah. So that simplifies to 5 by 3 grams.
5 by 3.
C part. How much copper zinc would you need to make a 9 carat alloy using 3 gram of pure gold? So this ratio is for 9 carat already. So we need 3 gram of pure gold. So I'm copying gold only, and the other is the comparison with copper zinc. So that is 12.5. And if I need this 3, this needs to be X. And cross
Will it
multiply.
ever ask us? Will it ever ask us to make like a comparison of like 3 different ones? Like this one, but
They could ask. So we will do it one time for silver and one time for copper, and then write both of them. Like I could use X for one, and in the same question I could write Y for the other. But we will be doing them one by one.
in parts. Okay.
Yes. So 25 by 6 or 4.17 grams. Okay, I'll share that question 2, 6 and 7,
Okay.
and then we'll continue from here. Probably this complete chapter has the same theme other than graphs. Yes.
Can you also send like the graded test to my mom's email as well?
Yeah,
Because
I'll do it once I get it.
yeah, because my dad might forget to send it again to us. So
Yeah,
just
sure. You should just remind it to forward it to me, and I'll whenever I check it, I'll send it to both places.
okay. And
Right.
also, could you send more like worksheets from question 2? And what was the other question?
Yeah, we have a lot of that. Like this one, the next complete exercise is on the same topic.
Oh, okay.
I think
Okay.
I'll just send the complete rather than cropping one of the question. So you would have the solved examples and those questions as well. So this was question 2. And see, if you just see, this is X ratio 20 and 3 ratio 4. And what did we just do in the latest question? Exact same thing.
Yeah.
So the book was ensuring that we could handle cross multiplication. And then see 21.3, this is something, this is the new exercise, but again, we have to divide 200 in the ratio 1 ratio 4.
Yeah.
So this would be actually 40 ratio 160. So if I know the ratio, I can split the mass. If I know the mass, I can make the ratios.
Oh, splitting. Oh,
Yeah.
okay.
Now see, 40 and 160, the total is 200, and they are in the given ratio.
Yes. So we divided 200 by 1/4.
200 by 5.
Oh, by the total, and then we would split it.
Yeah.
Okay.
C part, same way, we'll divide it by 10 and then give 3 ratios to one and 7 ratios to the other.
Okay.
Okay, for now, I'm just sharing these first two exercises, and there are 3 remaining questions. You can practice them, and inshallah, we'll continue from the next exercise tomorrow.
Okay. Thank you.
You Did you get that? Understand the answers? That was actually 21.1, and then the question number.
Yeah, I didn't like understand how to like align the answers with like the question answers.
Like, this is the exercise number 21.2, and then the question number and answer.
Okay. But when I was checking it, so let me pull out the paper. Okay. In the paper, I don't know. I didn't like understand how to align it. I don't know how.
Are you talking about this exercise?
Yeah, that exercise.
This question number 2?
Yeah, question number 2.
Okay, use the equation cross multiplying fractions method to find the unknown values. So we just write this first one first. X by
No,
20
I
is
knew
equal
how to do it, but like I don't know. I checked my answer. Okay. It was just kind of hard to align with like the I don't know, like the book, like the questions. Like the answer sheet.
This is 21.2, question number 2. This is 21.2, question number 2. A part, A part is 15. Can you see this now?
Yeah, I can see it.
Anytime you get this sort of questions, this the homework in this way, it's exercise number and then the question number and part number. If I would just look at B part, this is now like 12 by 21 is equals to x by 14. Cross multiplying 14 into 12 by 21 is equals to x. 7 2 times, 7 3 times, 2 2 times is 4. 7 1 2 2 3 and 3 1 times, 3 4 times, 4 2 times is 8. X is equal to 8. So B part, x is equals to 8.
Okay. I'll try doing it that way then. I'll do it with the exercise and then the question.
Yeah.
Okay.
And then these were the two questions, 6 and 7.
Yep.
Any issues?
No, I could look at those. Oh, yeah, it was just like the question 2.
Okay, dividing a quantity in a given ratio. Ratios can be used to divide or share quantities. There are two ways of solving problems like these. Method 1, find the value of one part. This is the unitary method. Add the values in the ratios and so on. Let me show you through a solved example. So let's say this is the question. Share $24 between Jess and Ann in the ratio 3:5. So if it is written in that order, I would know that Jess ratio is 3 and Anne's ratio is 5. So if I have to split it, this is actually 3 out of 8 for Jess. And it is 5 out of 8 for Anne. So 8 one times, 8 three times. 3 times is 9. So Jess is getting $9. And 8 one times, 8 three times, 5 three times is 15. So Anne is getting $15. $9 and $15. That's how we split in the given ratio. The other thing was if you just want to make it for one, $24 in total and 5 plus 3, 8 ratios in total. So we just do it for once. So one ratio is 3 only. And then you can multiply 3 into 3 and 5 into 3. Exercise 21.3. Divide 200 in the ratio 1:4. We just did that yesterday. Let's try B part. It says divide 1500 in ratio 4:1. The first part is 4 out of total 5 of 1500. So 5 one times and 300. 4 three times 12. Now there's one other way. I know that there's no other ratio. So if 1200 is already here, 1500 minus 1200 remaining must be on the other side. Going back to the solved example, in the same way, if this was already done, if I know that just share is 9, so Anne's share would be total minus 9, which is 15. You're getting the point?
Yes, but for the second value, how do we know which one is which one? Like which one is Jess and which one's Anne?
They're given in order, always.
No, not like that. I mean, like, so we first add them together and then we divide it by the 24, and then we get 3.
Yeah, it took 3. That was the first one, 3:5. 3 was the first one, and Jess was written first. So I knew that 3 corresponds to Jess ratio, Jess share.
Could you repeat how we got from 3 to 9?
Yeah, Jess had 3 portions out
Yeah,
of 8.
yeah.
So that was 3 portions out of 8 of 24 of the total.
Yeah, okay. No, I'm saying in like the answer sheet. So method 1 is just like the first part, basically.
Yeah.
Okay.
Which answer sheet are you talking about?
The work, like the method 1 under it. 3
Okay.
plus 5 equals 8.
Okay. He's doing it this way that he's first dividing it with 8 and telling us that one ratio is equivalent to 3 because 8 were total ratios. 3 plus 5 total is 8. One ratio is equivalent to 3. So if one ratio is 3, what would be 3 ratios? That would be 9. What would be 5 ratios? That would be 15. We already know one value of one ratio is 3. One part is 3, so 3 parts would be 3 into 3, and 5 parts would be 5 into 3.
Yep. Okay.
And method 2 is this one, which we already did. 3 out of 8 of the total. This is actually the same thing because when we did 3 out of 8 of the total, it could actually be written in this way. So this is actually giving me one part and then I'm multiplying it with 3.
But it's the same thing, both
Yes.
ways.
Yes. I have to split 50 in 3:7. So 50, 3 out of 10. So what would be 3 out of 10? We cross multiply. We just must multiply 5 3 times 15.
15.
So I know 3 represents 15. And there's no third ratio. These are only two. As it is in each part, there are 3 ratios. So I know if one section is 15, the other remaining would obviously correspond to 7. So that's 35. What I did for the second one is 50 minus 15.
Yep.
Try D part.
12 to 48.
Very good. E part.
$150 to $450.
Correct. Same way, 38 in ratio 11 by 8. So this is 11 out of 19 of 38 is 22, and remaining is 16. G part. 11 out of 15 of 300 is 220, and remaining 4 out of 15 of 300 is 80. So this is 220 ratio 80. Now we have 3. Can you try that? You think you can do it?
I'll try to do it. 209.1, 418.2, and
200 and first one is 200 and
209.1.
I'm getting 30.
30, 30.
Yeah, 230. What are the
I
working?
Yeah, I just basically did it as like part by part with the three. So 23,000 with times 1/11,
1 over?
1/10, 1/10,
Yeah.
sorry. And then I did the same with like the 23,000 times
See, when it
2.
is 1/10, the 0 of 10 goes with 0 of 2300, you're left with 230.
Did you say 230 or 30?
230.
Okay, 230. Okay, then I'll recheck the others as well. And then so it's 230, 460,
Yeah.
and 1,610.
Yes. Question number 2. Fruit concentrate is mixed with water in the ratio of 1:3 to make a fruit drink. How much concentrate would you need to make 1.2 liters of fruit drink? Okay. So 1:3 is there. And then now this is concentrate and this is water. How much concentrate would I need to make this 1.2 liters? I would need 1 out of 4 of the total 1200 mLs. So I would need 300 ml or 0.3 liter.
Should we write it as liters or milliliters? Or can we do either?
We can do either. If I'm converting it, I'm writing units along with that. So if I write 300 ml, that is obviously equal to 0.3 liters.
Okay.
Try number 3.
27 to 18.
Very nice. 200 is to be shared among Annie, Andrew, and Amina. In the ratio 3:5, how much will each child receive? So Annie is getting 3 out of 5, 6, 7, 8, 9, 10, 11, 12 of 200. 3 out of 12 of 200 is 50. And the second child is getting 4 out of 12 of 50 is 100 by 3. and the third child is getting 5 out of 12. That is 250 by 3, 83.33. Question number 5 says a line 16 centimeter long is divided in the ratio 3 ratio 5. How long is each section? So 3 out of 8 of 16 is 6,
6. And then 15.
and then 10. Total was 16. You take away 6, you're left with 10.
Oh, yes. 5 times 2.
Yeah. Try NPK, fertilizer, nitrogen, phosphorus, and potassium. Fertilizer contains this in the ratio 2:3:3. Work out the mass of each ingredient in the bag. Have the following masses. Okay. So if it has 1 kilogram already, I would say 1 kilogram is actually 1000 grams. 2 out of that is 3, 3, 6, 7, 8. 2 out of 8 of 1000. So 2 divided by 8 of 1000 is 250 grams or 0.25 kg. And other two are 3 out of 8. 1000 is 375 gram or 0.375 kg and 0.375 kg. Now, A part is already done for 1 kg. May I just avoid all the working and just multiply all these with 5 for 5 kilograms?
Yeah.
So 0.25 times 5 is 1.25. Ratio 0.375 times 5 is 1.875. Ratio 1.875. And then the same with 20. So 0.25 times 20 is 5.375 times 20 is 7.5, 7.5. And same with 25. So 0.25 into 25 is 6.25 kgs. 0.375 into 25 is 9.375 and 9.375. Try number 7.
180 to 225 to 135. Which that's in centimeters.
Okay, first one, please say that again. 180.
180, 225, 1 and 135.
135. 180 correct. 225 correct. And 135. All three are correct. Number 8 says a rectangle has a perimeter of 120. The ratio of length to its breadth is 5:3. Sketch the rectangle and indicate what lengths of each side would be. Can you do that? There's a small trick in this question.
Yeah, the perimeter doesn't make sense. When I do it,
Mm-hmm. You need to understand one thing in this, that if you have a rectangle, you do have the length and breadth, and then the length and then the breadth. So if we are
yeah.
splitting 5:3, we are not splitting 120, but we are splitting 60.
Oh, okay.
So that's 37.5 for the length and 22.5 for breadth. Now if we add them all four, we will get 120.
Okay.
Number 9. In a group of 3,200 elderly people, the ratio of men to women is 3:5. Calculate how many men are there in the group. So men to women, 3 by 8 of 3,200. So there are 1,200 men. 10 says show that the area ratio circumference for any circle is R:2. So area of any circle is pi r square and perimeter of any circle is 2 pi r. So I can divide both these sides with pi, left with r square ratio 2r. Then I can divide both of these with r, I'm left with r ratio 2. B part says find the ratio of volume ratio surface area of a sphere radius r, giving you answer as simply as possible. Do you know the formulas? Volume of sphere.
It's 4/3 pi r cubed, right?
By 3 pi r cube, right? And the surface area.
The surface area. Four
4
pi r
pi r square.
cube. Oh, squared. Okay.
Cube is for volume, square is for area. Try this.
Four over 3 pi to 4.
I don't think so. See, we first eliminate the similar things. Pi goes with pi. R square goes with r square. I'm left with 1r. And 4 goes away with 4. So I'm left with r by 3 ratio 1. And now multiplying both sides with 3. This is r ratio 3.
Can we multiply both sides? Wait,
Yep.
so we can move the 3 to the other side, right? So that's how we got
Yeah.
pi to 3. Okay.
Ratio and scale. Ever used Google Maps?
Yes.
So that would depend. You would remember that sometimes you see what is just across the street and what is just outside the town or outside the city. And you may have noticed that you can see the complete city on your mobile screen. So that is something which is ratio and scale. That is obviously in ratio. If you just zoom in or zoom out, you would see that what is in your next street and the size of houses. And then when you just zoom in and zoom out, those which are 1:2 to each other stays the same, but the size changes. For example, if I say this is my mobile screen and these are the two buildings, and when I just zoom in, they might appear like this on my screen. They're still 1:2 to each other, but sometimes they're small, sometimes they're large. When they're small, I might get a scale of 1 is to 5,000, and I might get a scale of 1 is to 250 in this case. This actually means that 1 centimeter on my phone is representing 5,000 centimeters in the real world. So this is a ratio and scale. Ratio would stay the same as we studied. Scale is something new which we will multiply to get the actual value. For example, if the scale is given, how we handle that handle scales is 5 ratio 1000. This is all. This should always be given in this form, 1 ratio n. So if we are given with 5 ratio 1000, I have to convert the first number as 1. So I'll divide both sides with 5 and I get 1 ratio 200. So this is my answer in form of 1 ratio n. Getting it? And we should have same units. So 4 millimeters to 50 centimeter. So I'm changing it into millimeters first. 50 into 10 is 500 millimeters. Now I can divide both sides with 4 to get 1 in the first place. So this is 1 and 500 divided by 4 is 125. So 1 ratio 125 in form of 1 ratio n.
So it's always going to be 1 ratio n.
1 ratio something or something ratio 1. One side needs to be 1. That's
Okay.
more understandable. So whenever you use Google Maps, you can now interpret that whatever is the size on your phone currently, if you would just multiply it with the given scale, you will get the exact dimensions.
Yes.
Do
Okay.
you have it now with you?
I can open it. I can open Google Maps.
Yeah, you just see in the bottom right corner, you will see that.
The 1 kilometer and then the distance, right?
Yeah, you just zoom in, you will see those numbers decreasing.
Yeah.
I can get up to 5 meters, which is 10 feet. 5 meter and 10 feet. I'm getting these two scales. Now in the bottom corner, you see that that's the line. I can see 5 meter, and above that I can see 10 feet. But I do see those lines as well, protruding outwards, upwards, and downwards. So that is actually telling me that this long thing on the map is actually 5 meters. So if I could just move the houses and just fit in, I can see one of the house that this length is 50 feet.
I can see that I can go up to 5 meters as well. And then,
Yeah.
yeah, it says up to 1.
So when we just zoom out, and can you see your town now?
Yeah, I can.
Now this much length is actually in the bottom. I'm just keep on doing it, and I can see 100 kilometers, then 500 kilometers, and 2000 kilometers. At 2000 kilometers, I'm looking at continents. If I just keep on zooming out, so that's the scale. The ratio is in its place, and this is the scale.
Okay. I see.
Why did I just miss out on the idea that I could really open it here? Where is my scale mark?
It's down.
Oh
Yeah,
yeah,
it's 200 meters now.
200 meters. So this much length. If I would just imagine that this is actually equal to this green length, so I know that this park is 200 meters by maybe 210 meters. This side seems a bit longer than that. Now this is 500 meters. So this much length anywhere would be equal to 500 meters. Now maybe this street is 500 meters and so
It
on. Now,
doesn't seem like a good, like, the way that Google Maps did it.
yeah, that's good.
No, but the way that they're measuring it with the line. Some
Yeah,
people might get confused.
basically now what I will actually do is I may have a compass in my hand and I can see this 2 kilometers. And now wherever I put this, that would be two. Can you see this model town written?
Yeah.
Just imagine this length. Is it just similar to this one? So this area is just 2 kilometers by 2 kilometers by 2 kilometers.
Yes.
For a rough estimate, that's a good thing. Now, if I just need to see from this blue point to this model town area, and this is 2 kilometers right here, I'm just using my thumb and finger to see that one jump, second jump, third jump, and I'm getting 3.5 jumps. That would mean that this is almost 6.5 to 7 kilometers.
Okay.
And that's just 12 because of all the lengths and distances through the roads.
But normally it's just
Normally, it would be like I was measuring the straight distance, and definitely it is through the roads. So
okay.
this is scale.
Okay, I see.
Write 22 ratio 4 in the form n ratio 1. So second part needs to be 1. So we need to divide both sides with 4. So this gets 1 and 22 by 4 is 5.5. 22 by 4 is 11 by 2 and then 5.5. Now see worked example. The scale of a map is 1 ratio 25,000. Before we enter the question, this means whatever is on the map, 1 centimeter on the map will be 25,000 centimeters on real ground. So, what is the distance between 2 points that are 5 centimeters on the map? So, if it is 5, that's x. So, x is 5 into 25 is 125,000 centimeters. Express the real distance in kilometers. So for kilometers, we know that we divide 125, 123. 1,000 centimeter to meter is 100. And then 123. We divide it by 100,000 and I'm getting 1.25. Any issue in this 100,000 figure? That 1 kilometer is 100,000 centimeters.
So we first changed it to centimeters and now we changed it to kilometers.
Yeah, that was already in centimeters in A part because of that 5 centimeter thing. 5 centimeter on map is 1,25,000 centimeter on real ground. So then in B part, he asked to change it into kilometers. So
Okay.
any issue in understanding that where is this 100,000 coming from?
No.
Okay, try this worked example.
0.04 meters. And then to centimeters, just times 100. And that would just be 4 centimeters.
That's right. Any issue in understanding the concept?
No, it's not. Just conversions, that's fine.
And that is also easy in the case where we understand what we are dealing with. For example, the word dam. So, in case if this question would have been about the cellular sizes, let's say plant cells or something, then the real thing would be smaller than those on the scale. Like, it is not necessary that every time the real thing has to be larger in size. You're studying biology,
Yeah, I am.
so you would have a good idea of that.
It's gonna be bigger. So you're saying that the real life would be smaller than the image, right?
Yeah. For example, if I just draw a cell
Yeah.
with the nucleus and cellulose and everything, in reality, it might be very, very small.
But it's just enlarged. Yeah.
S- So, after the examples, write and write each of the following scales as the ratio in the form 1 ratio and n ratio 1. So I need to see 1 in the first place. This is 1 centimeter to 2 meters, which is 1 centimeter to 200 centimeters. Now this is already 1 to 2. So I can write 1 ratio 200. And then the second one is 1 to 250. Would you agree? 2 centimeter and 5 meter is actually
Yeah,
500
you
meters.
simplified it, right? It was 2
Yeah.
to 500 and then give me 1 to 250.
Yes. So 4 centimeters to 1 kilometers. This is 4 centimeter and 1 kilometer is 100,000 centimeters. I'm dividing both sides with 4. This is 1 ratio. 100,000 by 4 is 250, 25,000. So 1 ratio. And I'm doing n ratio 1 for same, all of these, like the first three. I already have 1 ratio 2, 200. So in order to see 1 in the second place, I am dividing both of them by 200. So I'll get 1 on the right hand side and 1 divided by 200 is giving me 0.005. Same way, 1 by 250 gives me 0.004 ratio 1. And 1 by 25,000 gives me 0.1234 and 4 ratio 1. This is still 25 times of each other. 5D part, 1 ratio n and n ratio 1.
For n
Yep.
ratio 1, it's 1 to 200,000.
1 to 200, 1 to 3.
And then for the second one,
Are you getting 5 into 10 is for minus 6 when you divide it by 200,000?
sorry, 5 minus
5
6
into 10 raised for minus 6.
raised to the power of minus 6.
Yep. Like in your calculator, when you do 1 divided by 200,000.
Oh,
So that would mean you write 0
I get 0. Yeah,
0.5 and sixth number would be your 5.
at 0.00000005.
Yeah, like 5 zeros.
Yeah, and
Let's
to 1.
question number 2. I hope you get the idea of 1 ratio and n ratio 1.
Yeah.
A scale diagram of shopping center is drawn at a scale of 1 ratio 400. Find the real distance in meters of the following lengths measured on the diagram. So if it is measuring 1 centimeter on the diagram, I'm using this scale. So 400 times 1. This is 1 ratio 400. So it is just 400 centimeters on real ground. If it is 15 millimeters, so in real it would be 400 times 15. This is 400 times 15 and I'm getting 6,000 millimeters. Now that is your choice. Either the question will in meters. Sorry, that's not our choice. The question is already asking in meters. So 400 centimeters is 4 meters. Now this is 6,000 millimeters. I'm changing it into meters. I'm getting 6 meters. Solve C part.
14.
Correct. So this was already in centimeters. So we just divide by 100 and we get 14. And the next one is again in centimeters. 12 into 400 by 100 is 48 meters. Number 3, a map has a scale of 1 is to 50,000. How long would each of these real lengths on the map be? First one, what do you get?
I get 3 million.
No. This says a map has a scale of 1 is to 50,000. How long would each of these real length be on map? So on map, it has to be small. So this is 1 ratio 50,000. On map is unknown, real is 60 meters. So we cross multiply.
We divide both of them. Okay.
Yeah, this is in meters.
So it's 0.0012.
0.0012 meters. And that's not a suitable answer. So I'm just multiplying it with 100. I get 0.12 centimeter. And if I just multiply it with 10 again, that would be 1.2 millimeters. In this case, the examiner is not restricting. So if one leaves your answer in this form, all three would be accepted.
How would an examiner restrict it? They would say,
Like in question 2,
oh, okay.
he said find the distance in meters.
Okay.
B part.
Zero point zero 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 three.
Correct. So if I just do it like this is 1 ratio 50,000 unknown and 15 kilometers. So x is equals to 15 by 5123. This is kilometers. But if I just multiply it with 100,000, I will get in centimeters. So 15 kilometers, 30 centimeters on map. Getting it?
Yes. And then the same thing with the 120 kilometers.
Yes.
So 0.0024 times 100,000, 240 centimeters.
This is 120 by 50, 123 into 100, 123. Correct. 240 centimeters and 75.5 kilometers.
$1,510.
I'm getting 151 centimeters. Now that depends what is your unit.
I divided 75.5 by 5,000.
50,000.
Oh, yeah. Okay, so, yeah, okay, and then times by. So, yeah, 151.
A rectangular hall is 20 meters long and 50 meters wide. Draw scale diagram of this hall using a scale of 1 is to 200. B part is 4 millimeters to 1 meter. So first one 1 is to 200. It is 20 meters already. I'm dividing 20 meters by 200 and I'm getting 0.1 meter, which is actually 10 centimeters. And then 50 meters multiplied by 100 is actually 5000 centimeters divided by 200. So I'm getting 25 centimeters. So using the scale, I will draw 10 centimeters by 25 centimeters. Then the next one says 4 millimeter to 1 meter. 4 millimeter will represent 1 meter. So this is 20 meters. If I change it into millimeters, so meter into centimeter is 100 and then millimeter is one more zero. So this is actually 20,000 millimeters and that 50 is 50,000 millimeters. Now it says that 4 millimeter should represent 1 meter. Where did I take it? That was actually simple. 20 meters to x millimeters, 4 millimeter to 1 meter. So we just cross multiply and I get 4 2 times is 80 millimeters. And then x ratio 50 meters, 4 millimeter to 1 meter. And we cross multiply again. I get 200 millimeters. So we'll draw this. So either I change it into centimeters for my understanding. So this will be 8 times 20 rectangle. 8 centimeters and 20 centimeters on the page. Clear?
Yes.
Using map to find straight line distances between New Delhi and Bangalore, Mumbai and Calcutta, Srinagar and this. Now this is something which we were looking at Google Maps. Now see the first distance is New Delhi and Bangalore. So let's find it. Where's New Delhi? I found it.
Up.
New Delhi
Yeah.
and Bangalore.
Down. Down of India.
Yeah. So now what I'm going to do is either I use a scale or I use this compass pointers. So I just need to see what is the exact distance between these two. Let's say I use these pointers and then without changing this angle, I come back to the scale. Now in this case, definitely this is small and this is large. So what I can do is check it in the reverse order. Start with the scale. I have drawn a straight line here. And let's say I measured this distance 200 kilometers. And then I mark here and then I lift the compass and keep on marking and I can count what is the distance between these two cities. Is this thing clear?
So we just mark it with the 200.
Yeah,
And then
you see, this is the
the-
straight line. We place the needle here off the compass. This is the needle. And on the other side, we attach a pencil. We use that to draw circles.
Yeah.
So if I just use this compass and I see that this distance is 200, I place my needle at 0, my pencil at 200. Then we draw this line and start from New Delhi and draw an arc. Now this arc is actually 200 kilometers. Then you lift the needle, place the needle at the arc and draw another arc. And you keep on doing that. And you can count how many 200 kilometers are these?
Oh, okay. And it can also be done with the others as well.
Yes, in the same way. Okay. Question number 6. The scale used for this floor plan is 1 is to 150,000. 1 is to 150. What is the real distance in meters is represented by 1 centimeter on the plan. So 1 centimeter on plan in meters is 150 centimeter on real ground. So that will be 1.5 meter on real ground in meters. Would you agree?
Scale 1 to 150, and then it's
Yeah, is this 1.5 meter correct?
what is the real distance in meters represented by 1 centimeter on the plan? So the
Okay.
scale shows centimeters, and then from that we just
Which
change
part
into
are you talking about? I'm still on A part, 6A.
yeah.
So it is 1 ratio 150. That means 1 centimeter on map is 150 centimeter on real ground.
Yes.
And the examiner wants you to convert it into meters.
Yeah. Okay.
So
So
we just simply
150 to 1 meter. So
divide it by
by
100.
100 and a 1.5. Yes.
Yes. Calculate the real length of the length in meters of the length of living room. Now, where is the living? This is the living room. Now, what we will do, remember to measure from inside walls to inside. Now, this is actually a soft copy, so the distance keeps on changing while I'm zooming in and out. So, let's suppose this is our fixed distance. What we will do in reality while solving this question when it is on paper, length of living room. I'm going to measure this distance from this green wall up to this green wall. And whatever this distance is in centimeters, I'm going to use it here. Let's suppose this is 4 centimeters. So I'm just going to use it here. And I'm going to get 600 centimeters. And then that would be 6 meters. Does it make sense?
Yes. Calculate the length of it, measure it, and then change it into meters.
And same way, we'll measure breadth and length of path and breadth of terrace. What is the area of bedroom 1? Now let's see how we'll handle areas. Now this is bedroom 1 in bottom left corner. So if I have to measure it, area, I would need 2 dimensions. One is the length and the other is the breadth of the bedroom. And not till there. This is something on the other side. Till this point, right?
Yeah.
Whatever this will be, there are 2 ways. Let's say this is some centimeters. We'll first write them in meters and then multiply both of them and get area in meters. The other thing is you just find it in centimeters and then divide by 10,000 to convert it into meter square. Any issues?
So we get the area of the bedroom
Yes.
and then multiply it by 150 and then we divide it by 10,000.
No. We first measure it in centimeters.
Yep.
And yeah, right, yes, we convert it into in reality in with 150. So that is again in centimeters, still in centimeters. So now either you change it into meters before calculating the area, or you just calculate in centimeters and later divide by 10,000 for area in meter square.
Okay.
Like 1 meter square is actually 10,000 centimeters square. 1 meter is 100 centimeters, and 1 meter square is 10,000 centimeters square.
So there's just like a difference of 100 basically.
Yes.
Okay.
Okay. So actually, there was a limitation of the resource in this type of question that needs to be measured and then solved. So we just discussed it. We'll start with the rates in the next class, and I'll probably check your test today or tomorrow morning and send a new one for the next 4 topics.
Okay.
So just revise these or maybe those 4 topics for now, and I'll share it soon, probably tomorrow. The
Okay,
next,
I'll revise the next 4 topics
yeah,
and then I'll do the test tomorrow. Okay.
or 60 kilometers per hour. So one value is given in relation to the other 1 unit. One value is given in relation to other 1 unit. Let's go through worked example. 492 people live in an area of 12 kilometer. 492 in 12 kilometers. So how many people would live in 1 kilometer is 41 people in kilometer square. We also call that population density.
So finding how much people live in a kilometer is population density?
Yes,
Okay.
unit could vary. You may ask in any units. So currently for this given data, we have 41 people per kilometer square. That is very low population density.
Okay.
Average speed. Speed is distance per unit time, and specifically average speed is total distance over total time. This is one of the way to memorize the formula. The other is distance is equals to speed into time, and we can always rearrange distance divided by time is speed, and distance divided by speed is time. A bus travels 210 kilometers in 3 hours. What is the average speed in kilometer per hour? So speed is distance over time. Distance is given 210, and hours we have 3 hours. So
So
this is
70.
20 kilometer per hour. I walk at a 4.5 kilometer per hour. How far can I walk in 2.5 hours? Now the distance again here is unknown. So distance is equals to speed into time. Speed is given that a person can cover 4.5 kilometers per hour and he is walking for 2.5 hours. So when we multiply, we get 11.25 kilometers. How long would it take to cover 200 kilometers at the speed of 80 kilometers per hour? So distance is given, speed is given, time is unknown. Time is equals to distance divided by speed. Distance is 200, time is 80. So 200 by 80, I'm getting 2.5. So it would take 2.5 hours to cover a distance of 200 kilometers traveling at a speed of 80 kilometer per hour. Here comes the practice exercise. Express each of the following relationship as a rate in its simplest form. And this is 12 kgs for $5. So 12 kg divided by $5, I'm getting 0.6 kg per dollar. Does that make sense?
Yes.
What did I do? That is 2.4. I divided it with 20. So this is $2.5. 120 liters for 1000 kilometers. So 1000 divided by 120, and we can cover 8.33 kilometers in 1 liter. $315 for 3 nights.
So it's the same for all of them, right? Just
Yes.
dividing the to find the rate, the highest divided by the lowest.
Sometimes it is actually not the highest number. So it is the unit we want to express. For example, the first one, that was the amount for the price. So we can get 2.4 kgs for $5. And in other ways, that is like per dollar. I can also express as at per kg. So if we do it, 5 divided by 12. Now numerator is price and denominator is the weight. So 5 divided by 12, it gives me 0.416. I'm rounding it off, $0.417 per kg. Dollars per kg. So the units are important. And in the other way, if I just make a reverse of this, that was 120 liters per 1000 kilometer. So we can say 0.12 liter per kilometer. Either I say we can travel 8.33 kilometers in 1 liter, or we can say 0.12 liters would be consumed in every kilometer. So the units are important.
So
You can divide it either way.
it can be either way, right?
Yes. Let
And
me make the calculation easy. For
okay.
one example, if say we are traveling in a car and we know that 10 liters of fuel will be used for 100 kilometers we travel. So I can do it either way. I'm making this as 1. So this would be 10 kilometers. I can say 10 kilometer per liter. Would you agree?
Yep, 100 divided by, because we multiply the 10 liters with the 10 kilometers,
Yes.
and then
And
the with the 100.
now I'm using this same data in the first line, but this time I'm making the distance as 1 kilometer. So basically it is 100 times less. So on left hand side, again 100 times less would be 0.1 liter. So I can say 1 kilometer, that is 0.1 liter per kilometer. That is just the marketing, the way we speak, the way we say. For example, the salesman is telling you that the car travels 10 kilometers on 1 liter. So you'll definitely have the price on your mind. Or he says it would cost you zero point 0.1 liters to travel 1 kilometer. Both are exactly same.
So we can answer either way.
Yes.
Okay.
So I just avoided like decimals. That is why sometimes I kept not, I couldn't avoid decimals, but I was not willing to get it less than 1. So I divided 12 by 5. I divided with the next number. But in this case, I chose to divide it with the first number. Kilometers per liter, kgs per dollar. So the units are important.
Yep. Okay.
So now normally this is $315 for 3 nights. So normally we would see what is the cost per night. That is why divided by 3. If I would do it reverse, 3 divided by 315. So 3 divided by 315, that is giving me 0.009. 0.009. Now that would be nice to hear that we can stay 0.009 nights per dollar.
So
If I just multiply it with 24, that is giving me zero point 0.2 hours per dollar. Again by 60, that is giving me 13 minutes per dollar. So sometimes we need to see what is around us, which unit would make more sense. For example, if I just tell you that while you come back, just bring 1000 ml of soft drink, 1000 ml of orange juice. I would have just said 1 liter.
yes.
So more convenient units, which are more used around us, they are like $105 per night.
Okay. So which one is easier for us to do in a shorter amount of time?
Which one would make more sense? Whatever the time is.
Okay. So how many questions like this would we have? Like
On exam one,
one. Okay.
and there is actually no restriction like this number D. See, 5 kilometers in 20 minutes. So if I just divide 20 by 5, I know the numerator was minute, I'm getting 4. So 4 minutes per kilometer. We'll take 4 minutes and we'll cover 1 kilometer. And if I do it in the reverse order, 5 in numerator divided by 20. So 5 divided by 20 is giving me 0.25 kilometers. 0.25 kilometer per minute. They are exactly the same, just the representation. Or it would take 4 minutes for 1 kilometer, or it would take 0.25 kilometers to cover every minute.
Okay.
If I just change kilometers into meters, I can also say 250 meters per minute. So
Will it
the
ask us to
units
do
are,
that ever?
in this question, he's saying nothing, but yes, he may say that give your answer in this form. Look at question number 6. He says 230 kilometers per hour travel in this much hours or this much minutes.
So we have to convert between them.
Yes, they can ask you that convert that in th- this unit. So the question one is just leading through the division process and the ratio.
Okay.
Try question number E, 1E.
27.
Correct. So the units will be 27 students per teacher. Number 15 is 15 hours spent, 5 holes dug,
So 3 hours for each hole.
3 hours for each hole. Now, if I just do reverse for this, that is 5 divided by 15. That is not very soothing to hear that 0.3 holes dug per hour. So, what amount of job is done? That also depends in our surroundings, which units we should be using.
Okay.
Okay, a query produced 1200 tons of crushed stone per hour. 12,000 tons of crushed stone per hour. How much stone could it supply in 8-hour shift? So simply 1 hour is 1200 and 8 hours would be 1200 into 8. So it provides 9600 tons in 8 hours. Now see the units. He's just asking how much stone. The first unit was actually 1200 ton per hour. Now this unit is only tons because he's asking the amount of crush would be produced.
So we just write the amount.
Yes.
And then 5 shifts. It doesn't say 5-hour shift.
Yeah,
So,
5 shifts. So one shift is already given.
so just times 5, 1,200.
No, nine. This is an 8-hour shift. So
So
90
9,600 times 5.
times 5, yes. So that is 48,000 tons could be produced in 5 shifts. Number 3. Water leaks from a pipe at a rate of 5 liters per hour. How much water leaks from a pipe in a day?
So times 24.
That's right. So 5 into 24 is 120 liters per day. And how much in week?
Times 7, 120.
120 times 7. That's 840 liters per week. Okay, a machine fills container at a rate of 135 containers per minute. How long would it take to fill 1000 containers?
So we just set up the proportion. So 135 over 1, and then 1,000 over x. And then we cross multiply.
135 takes 1 and 1000 would take x, and we cross multiply, so that is 1000 by 135 in fraction form, and in decimals is 7.4. And it says how long would it take to fill 1000 containers at the same rate? So 7.4 minutes. Number 5. Riku walks at 4.25 kilometer per hour. How far will he walk in 3 hours?
So that's the
Speed,
speed and the distance. No.
speed is given, time is given, and distance is unknown.
So we just multiply them.
We just multiply them. So 4.25 times 3. If you just see the units, that also makes sense. That was kilometer per hour, and we are multiplying with hours, so we will be left with distance. This is 12.75 kilometers. Number 6. How far will a train traveling at 230 kilometers per hour in 3.5 hours?
So
So
230
230,
times 3.5.
3.5. So we're traveling 805 kilometers, and in
And
20 minutes. 230 kilometer per hour. Does this make sense? Dividing by 60.
because it's in hours, we have to divide by 60.
Yes. So I'm getting 76.7 rounded kilometers. A plane flies at an average speed of 750 kilometer per hour. How far will it fly in 25 minutes? That is 312.5 kilometers in 25 minutes. In 4 hours,
So 750 times 4.
it is 3000 kilometers. A train left Serio at 9 p.m. and traveled the distance 800 kilometers to Aswan, arriving at 5 a.m. What was the speed? So 9 p.m. to 5 a.m. Now 9 p.m. to 12 p.m. is 3 hours, and then next 5. So total 8 hours. Distance in kilometers divided by time in hours. So 880 by 8 is 110. 110 kilometer per hour. A runner completes a 42-kilometer marathon in 2 hours and 15 minutes. What was her average speed? Average speed is total distance. The distance is 42 kilometers.
And the time is 2 hours and 15 minutes. So
Yes,
we can just do it as 120 plus 15.
that is correct. That would be kilometer per minute.
So it can also be 2.25. And then we divide them and then we get the average speed.
So this is 18.7 kilometers per hour. In August 2009, Usain Bolt of Jamaica set a world record by running 100 meters in 9.58 seconds. Translate speed into kilometer per hour. That is 100 meter and time is 9.58 second. Now I have to change this into kilometer per hour. Meter to kilometer. It is the conversion is 1000. So I can divide it by 1000. Now the numerator is in kilometers and 9.58. I can divide this with 3600 to convert seconds into hours. So this simplifies to this 3600 over 1000. So I can say when we are converting from meters per second to kilometer per hour, I can multiply with 3600 over 1000. And when we go from kilometer per hour to meters per second, we can multiply with 1000 over 3600. So simply 100 divided by 9.58 times 3600 divided by 1000. Getting
3600 divided by 1000.
yeah 37.578 approximately equal to 37.6 kilometers.
So simply for 100 meters in 9.58 seconds, we did kilometers to hours by first finding the speed because we had the distance and the time.
Yeah, because he was asking in kilometers per hour, the
And
unit
that's the
speeds
speed.
that we
Yeah.
are changing the speed. So this is kilometers and this is hours. Meter to kilometer, seconds to hours. So meters per second to kilometers per hour. How long would it take him to run 240 meters if he could run it at the speed?
Wait, sorry. For A, after we multiplied of like the top by 1000 and then the bottom by 3600, we divided and then we got 37.57, right?
Yeah, kilometers per hour.
Okay.
So now he's covering 100 meters in 9.58, so 420 next. 100 is 9.58. 420 next. Cross multiplying 9.58 times 420 divided by 100. So it's taking 40 seconds. 40.236 approximately equal to 40.2. I'll write to 4 because it's taking time to two decimal places. So 40.2 seconds. Any doubt?
No.
Okay. Kinematics. Distance time graph, we will have speed time graphs, we will have acceleration time graph. So first of all, distance time graph, just the overlook of it. This graph can give me distance and this graph can give me speed. So if I need to know what is the distance traveled in 12 minutes, so I can use this graph and find what the distance is in 12 minutes. One thing, if someone says after 7 kilometers, how much time was passed? So I can check that. So this graph is giving me time and distance and speed. Now distance divided by speed, distance divided by time is speed. Distance over time. So if I just look at the gradient, that is y2 minus y1 over x2 minus x1. In other words, change in y is basically change in distance and change in x is basically change in time. So distance over time would give me speed. And I can also say that whatever this object was traveling with some speed, which is 1 by 4, that was traveling with 0.25 kilometers per minute. And then the speed was 0. It was standing somewhere from time 4 to 6 minutes. And then again in the second section the speed was more because it is more steeper. Change in y is 7 in 10 minutes. So it covered 7 kilometers in 10 minutes, that is 0.7 kilometer per minute.
So for the first part, where you said it was going faster,
Yeah.
so we
In the
have
first
to
part it
find.
was slower because the gradient is less.
So we have to find a gradient to find the speed, right?
Yep.
So the gradient is basically the speed.
Gradient is speed, yes. Distance time graph, gradient is speed.
Okay. So could you redo like the longer, like the steeper slope?
Yeah. I'm looking at this triangle. So change in y is 7 and change in x is 10. See, from 8 to 1, the change is 7, and 6 and 16, the change is 10. We can also do it that way, like coordinate geometry. If I see these coordinates are x16 and y8, and these coordinates are x6 and y1. So 16, 8 and 6, 1. So y2 minus y1 over x2 minus x1 is 7 by 10, 0.7. And y was distance in kilometers and x was time in minutes.
Okay.
So 0.7 kilometers per minute
Okay.
or 700 meters per minute.
If we were to convert it. Okay.
Okay, now what does it say? Look at the graph. You can see that it shows the following journey: a cycle for 4 minutes from home to bus stop, and 1 kilometer away, a 2 minute wait for the bus. And then 7 kilometers journey from by bus takes 10 minutes. So the explanation of the graph. Worked example: Ashraf's school is 4 kilometers from home and it takes him 40 minutes to walk to school. One morning, he leaves at 7 a.m. After 15 minutes, he realizes he has left his book at home and he runs back in 10 minutes. It takes him 3 minutes to find the books, and then he runs at the same speed to the school. The graph shows his journey. Now, the graph is already drawn. In some questions, they would ask us to draw the graph.
And they would just give us the top, right?
Yeah, just understand that a school is 4 kilometers away. So that's 4 kilometers, and school is marked. And it takes him 40 minutes to walk to school. If he is traveling at that rate, at 7, this is 7, this is 8, these are 60 minutes. So 40 minutes is 40 by 60, that is two-thirds of the section. Or we can just use the x-axis and see what one box means. So I can see this is 7 and this is 7:10. So this one dot actually represents 1 minute. So 40 minutes, I need 40 boxes, 10, 20, 30, 40. So how this graph would have been drawn, at 40, he should reach school at this point. If there was no lag, he's not going back, nothing wrong is happening. So we would mark these 2 points, use pencil and scale, and along this line, he should reach school in 40 minutes walking at this pace. But what happens one morning, he leaves at 7, and after 15 minutes, he realizes, so I will just place my ruler in these 2 points. But after 15 minutes, these are those 15 minutes. And when I start marking, drawing the line, I would just stop here after 15 minutes. He walked towards school for the first 15 minutes and then realizes he left his book home, boots at home. So he runs back in 10 minutes. So from 15, 15 plus 10 is 25. So he reaches home at 25. From this dot to this dot, we draw a straight line. And then it took him 3 minutes to find the boots. So three boxes, horizontal line, no distance is being covered, but time is passing. And then he runs at the same speed to school. Now I need to understand what is the same speed. So
So that's
basically,
the slope.
the running speed. He was covering 1.5 kilometer in 10 minutes. Would you agree? This 1.5 kilometers, this is 1.5. He
Yes, and then
covered
this.
1.5 in 10 minutes. So
Yes.
now from this point, when he runs back towards school, 1.5 kilometers is the vertical distance and 10 minutes. So 10 minutes would mean 10 boxes on the horizontal ground. This is 1, 2, and this point is those 10 minutes. So in these 10 minutes, he covered 1.5 kilometers. Now I have these two dots. I will place my ruler in these two dots and start drawing a line, and I will not extend it because I know I have to stop at school. So we stop there. This is how the graph was drawn. There will be questions asking us to draw the graph.
Okay.
Okay, now we've understood the graph, and let's see what he's asking. How far had he walked before he remembered? So he walked till this point, that was 1.5 kilometers. What happens to the graph as he returns home?
It uh drops down.
Yeah,
It's a
basically,
negative slope, basically.
that's a negative slope. What is happening to the graph? The graph actually, this was the graph of distance from home. So the distance from home is reducing as he's going back. So the graph drops back to zero.
So we would write the distance is decreasing, so the graph
Yes.
drops back to 0.
Yes. Yes. So what does the horizontal line on the graph represent? This section.
It shows that like how many minutes he was in his home, like for 3 minutes.
That's right. The horizontal graph shows he was at home and no distance was covered. So maybe speed was zero and he's not moving away from the home. Then how fast did he run in meters per minute to get back home? So he covered a distance of 1.5 kilometers in 10 minutes. 1.5 kilometers. Now he needs to know in minutes, meters into 1000, and it took him 10 minutes. So this is 1500 meters in 10 minutes. So he's covering 150 meters per minute. And Hussein Bolt just covered 100 meters in 9.58 seconds. Practice exercise. To supermarket and back again. While I'm reading this, I'm just judging that she goes away towards the supermarket, stays there for some time, and then back home. Right?
Yes, she stays at it for a few minutes and then goes back.
Yeah. How far was Monica from home at 9:06? So first we need to understand what is one box showing. These are 10 boxes in 10
One.
minutes.
So 1 box is 1 minute.
One box is 1 minute. So 6 minutes are till this sixth point. This is 906. And we go up and go up and go up and find the point of intersection, which is this. Now on the y-axis, this is 400 meters in 10 boxes. So 400 by 10, one small box is representing 40 meters. So this is 4, this is 600 in between 4 and 8. So these are 1, 2, 3, three extra boxes. So I would just know that this is 600 meters already plus 3 extra boxes. One box represents 40 using calculator. And I'm getting 720 meters. So at 906, she is 720 meters away from home. B part. How many how many minutes did she spend at the supermarket? Can you do that?
Yes. 7 minutes.
7 minutes. 7 horizontal boxes. So 7 minutes. Next says at what times was Monica 800 meters from home?
So we just go up to the 8
That's
at
right.
800 and then we go down.
So 800. One is this seventh box. So at 907, she was 800 meters away. And one is this box. And the second time was 921 when she was 800 meters away from home. B part. On which of the part on which part of the journey did Monica travel faster, going to the supermarket or returning home?
So that would just be the slope.
Yes. So which one was faster? There are two things. We actually do not need to calculate it, but just observe. So how long did it take her to reach the supermarket?
It took her 10 minutes.
10 minutes. And how long she took to return is definitely more than 10. So on which part of the journey? Going to the supermarket or returning? So that's going. That was faster because she covered 1200 meters in 10 minutes. And on the return journey, she covered 1200 in 10, 11, 12, 13 minutes.
So going was faster.
Going was faster. We can also calculate it, but there's no need. The question is not asking for it.
Okay.
Number 2. Umar left school at 16:30. On his way home, he stopped at a friend's house before going home on his bicycle. The graph shows this information. How long did he stay at his friend's house?
So that's from 17 to 17 point 1735. So
Uh,
35 minutes.
so we can't say that that's 35 because see, these are 30 only. Maybe you
Oh, yeah, 15 then.
yeah. So this is actually
45 minutes.
1745.
Yep. So
It is
45
always
minutes.
advisable that you count boxes to avoid these mistakes.
Okay.
So this is actually 30 minutes and 10 boxes. So 30 by 10, I know this is 3 minutes per box, right?
Yes.
So I clearly can see that these are 15 boxes. So 15 into 3 is 45 minute. And yes, no restriction. If you can read the graph clearly, what this point means, this is between 1730 and 1800. So that is definitely 1745. So from 17 to 1745 are 45 minutes. Try B part. At what time did Umar arrive home?
At 18.
No. See the red line.
Oh,
Now, how many boxes are there before 18? Small boxes.
how many boxes before 18? Two?
Two boxes. So he actually reached at this time. One box was
So 6 minutes before 18.
6 minutes before 18. So may I say he reached at 1754?
Yes.
C part. Umar's brother left school at 1645. He walked home using the same route as Umar. If he walked at 4 kilometers per hour, work out the time the brother passed Umar's friend's house. Now we are going to sketch it. He left school at 1645. So I'm marking a point at 1645 and at school. Can you see that?
Yeah, I can see the point.
And walked home using the same route as Umar if he walked at 4 kilometers per hour. Now this is already 4 and I'm coming down. If this is the point, is traveling 4 kilometers per hour. So this is 1645 and this is 1745. That would make 1 hour and is covering 4 kilometers in 1 hour. So my second point is this right here.
How, so he left at 1645 and he walked 4 kilometers per hour.
Yeah, we can also say that this stretch is 1 hour and he's covering 4 kilometers. So see the y-axis, this is already 4. So right at the bottom. So he covered this distance.
So he would have reached home at that distance.
Yeah, traveling at this constant speed, he would reach home. Let me try to draw a straight line. I'm just trying that in half the time he would have traveled half the distance and another half, getting some points. Definitely this is not required in exam. You will use your ruler and pencil. I'm making this because of my limitations and trying to get this straight line. Yeah. So Umar's brother left school at 1645, walked home using the same route as Umar. If he walked 4 kilometers per hour, work out the time at which the what time Umar's brother passed Umar's friend's house. So he passed at this point, which is 1715. Any doubt?
No.
Okay. Question number 3. A swimming pool is 25 meters long. Jasmine swims from one end to the other in 20 seconds. One end to the other in 20 seconds. She rests for 10 seconds and then swims back to the starting point. It takes her 30 seconds to swim this second length. Draw a distance time graph for Jasmine's swim. How far was Jasmine? So, okay, just try to sketch it, then I'll do and we'll compare. Let me know when you're done. Only A
Okay.
part. I will just try if I can make that on the software to get exact answers. Still doing?
Yes. Okay, I'm a little confused
Yeah.
with the. I did the graph, but I'm a little confused with like drawing inside of it now.
Okay. So it says a swimming pool is 25 meters long. Jasmine swims from one end to the other in 20 seconds. So see, this is my distance time, axis time and distance is in meters and time is in seconds. So she's
Yes.
swimming 25 meters in 20 seconds. So on the horizontal axis, I see, let's say this is my 20 and on the vertical axis, this is my 25. So she swims 25 meters in 20 seconds. 25 meters in 20 seconds. This is my first section. And then she stays there for 10 seconds. So on the horizontal axis, that would be now 30. Distance is same. She is 25 meters away, one length away from one end. And then it says she then swims back to the starting point. It takes her 30 seconds. The time is already at 30. Another 30 would mean 1, 2, 3. This is 60. So she swims back. This is how your graph will look like. Now, she says, how far was Jasmine from her starting point after 12? These questions could be done in many ways because I know that she is traveling 25 meters in 12 seconds. That means 20 in 20 seconds. 25 divided by 20, her speed is 1.25 meters per second. So he's asking after 12 seconds, I'll just multiply with 12 and I can get the exact answer, which is 15. That was one way because I know the speed and I know the time. But we will use this graph that after 12 seconds, so I can see this and I can read the value from the graph, which would be 15 meters. Again, the limitations because I'm not drawing it on the exact graph, but see from here that at point 12, when x is 12,
Yep, I can see.
so at x 12, we can see what the point is on y axis. I had that option. Yeah, intersection. So see, at x12, y is 15. And the other section would say, how far was Jasmine from her starting point after 54 seconds? So again, use the same graph and see where 54 is and see after 54 seconds how much from the starting point. So at 54, we can read that again. When x is equals to 54, definitely you're understanding that this is actually not the need. On the original graph paper, you can just read it straight away.
Yep.
So this is 5 meters away from the original starting point. Any confusion, any doubt in distance time graph?
No, because I already drew like the basic outline of the graph. I just had trouble like making the points inside of it, but now I know. And then I also know how to read it.
Okay. So the next is this speed and distance time graph. The speed is, we've already discussed that it is the gradient of the distance time graph.
Yeah.
If you just give a quick look at the graph, walk, cycle, and drive, so you can see that in 10 minutes, the vertical distance covered is less. Then when you are looking at the cycle part, in the next 10 minutes, more distance is covered. And then in the drive part, in the just 10 minutes, even more distance is covered.
So it's
So
accelerating.
if we keep the time constant, more the distance is covered. So it is more steeper, it is more fast. Straight line graph indicates constant speed, one thing. Steeper the graph is greater the speed, that is greater the gradient as well. And upward slope means the graph is curved upwards, that means increasing speed. Basically the gradient is increasing, so the speed is increasing. And a downward slope would represent opposite direction, that is obviously it is coming back. And if it is straight line, this is constant speed going away, this is zero speed horizontal line at rest, and that is again constant speed but negative gradient shows it is coming back. And we could represent with the decreasing slope, constant slope, and increasing slope. So this first section is decreasing slope, that means it is moving away but with decreasing speed. Constant line, it is at rest, and then increasing slope, it is coming back with increasing speed.
So the first part is decreasing.
Yeah. And
So it's,
how are we so sure that it is decreasing? I can uh, imagine a tangent. So see, the line is less steep, so the gradient is decreasing, the rate of speed is decreasing. Your question, please.
sorry?
Your
My
question, please.
I still don't understand how it's decreasing.
Okay, let me draw that again. And more writing space. See, this is distance and time graph. Distance on y-axis and time on x-axis. Let's say in meters and in seconds. So if I just draw this straight line, it is covering constant distance per unit time. But if I draw this, you see it covered this much distance in 1 unit, and I'm keeping the x-axis same. So first it covered this much distance in first section, then in second section, then in third section, then in fourth section. You see the decrease for the same time. If I say this is time 1, time 2, time 3, time 4, for same time it first covered a greater distance, then the distance is decreasing because the gradient is decreasing, the speed is decreasing per unit time.
Because less space is covered.
Yes, less distance is covered in same time means the speed is decreasing, which is a reflection of gradient, because speed is distance over time, which in this is gradient, change in y over change in x. On y-axis we have distance, on x-axis we have time. So this is showing decrease. And if I just extend the graph like this, now that is showing an increasing speed in the next section, because keeping time constant is definitely showing more rise in y-axis.
So if it's curving inwards and it's increasing, if it's curving outwards and it's decreasing.
I won't use those complicated words. I will just go with gradient because like that would be the language in the exam.
Yeah.
Either gradient or tangent.
So the gradient is increasing or the gradient is decreasing.
In the
Okay.
next section, if I draw this tangent, let me name it 1 and draw this tangent. So tangent 2 is more steeper. So as the time passes, the steepness increases. That means it is increasing speed. Now let me make 3 sections for a good comparison. One section, second section, and third section. So in first section, what do you see?
First section is decreasing.
And second section,
Is stable. It's not increasing or decreasing.
and the third section,
And it's also decreasing. Oh no, it's increasing.
it's increasing. So speed here is increasing, speed here is 0, and speed here is decreasing. So my bad. Speed here is decreasing because the gradient is decreasing. The tangent is less too. Speed here is increasing, and in the middle, the speed is zero because the gradient is zero. The tangent shows zero gradient.
What did the tangent mean again?
Sorry,
What did the tangent mean again?
tangent would just show you the slope. If I need to find the gradient at any given point, I am drawing the tangent at that point. If I need to find speed at this point, I will draw tangent at this point. So it is going less steep, the gradient is lesser. So the
Okay.
speed is decreasing. On the other side, let's just say this is point 1 and this is point 2. So at point 1, the tangent is this, and I can find the gradient by drawing the triangle. And at point 2, the tangent is more steep, the gradient will be more, the speed will be more, and definitely with the negative sign, which shows it is returning back to the original point
Okay.
because it is a distance time graph.
Okay.
So coming back, let's read the description. The distance time graph shown in for a person who walks, cycles, and then drives for three equal period of time. For each period, speed is given by distance traveled per unit time. So time we've kept that constant, and distance traveled is this, and then this, and then this. So more distance and same time is definitely more speed. More steeper graph means more speed. Straight line, constant speed. Increase in y coordinate by increase in x coordinate is constant. Rise over run is constant. Change in y over change in x is constant as it is a straight line. For distance time graph, positive gradient indicates that the object is moving in the direction of increasing y and away from the starting point. Negative gradient would indicate that the object is moving in direction of y and it is decreasing, so it is returning to the starting point. So distance over time is speed. So let's see an overview. Constant speed, zero speed, constant speed, zero speed, constant speed. A to B, constant speed moving away. B to C, zero speed at rest. C to D, constant speed returning back. D to E, at rest. E to F, constant speed and negative gradient returning back. It says the travel graph represents a car's journey. The horizontal sections have zero gradient, so the car was stationary during these times. Now the gradient in the first section, A to B. So can you see the letter N?
N?
NB is the rise. Yeah, N, nest.
Yep.
This letter. So NB is the rise, which is 40 kilometers in 0.5 hours. So 40 by 0.5 gives you 80 kilometers per hour speed. And for section CD, I can see that the change is 40 to 20. The change is 20 and the time is 0.25 hours. So 20 by 0.25 is 80 kilometers. So this is actually the same rate. If I would draw full lines, you would see that the slope is same, but with negative sign.
Yep.
And then we have EF. So it covers 20 kilometers, but this time in 0.35 hours. First it was 0.25, now this is 0.335, and you can see this is actually less steep than the line before that. So traveling slower, but negative shows towards the original point. Practice exercise. 21.7. Clearly describe what is happening in each of the distance time graph below. B part says suggest a possible real life situation that would result in each graph. Okay, so let's see at the first one. What is happening? An
A
object is,
constant- yeah, an object is increasing at a constant speed
yeah. So
and it's not
traveling at
stopping.
constant speed.
And it's not stopping or decreasing.
Yeah. So it is traveling at constant speed. May I say a real life example? Car traveling at constant speed.
Yes. Without any like stop signs or red lights.
Yes. Now, second option.
So it's basically there's no increase or decrease and the
Speed is
zero.
because the gradient is zero. So may I say the object is at rest away from the original point or away from the starting point?
Yes.
Option D. This is similar to the first section. So an object is traveling at a constant speed away from the starting point and then it returns back at a faster rate.
So object is traveling at a constant speed and then returns back at an accelerated speed.
We will not use the word acceleration because acceleration means changing speed. This is constant. Faster, you
Mhm.
can use the word faster and you can add the word constant with it because accelerated would mean this.
Oh, okay.
See, tangent,
Yeah.
then another tangent, then another tangent. It is changing. But in
Okay.
this case, it is constant.
So it's at a constant speed and going faster at a it's going back at a faster speed.
Yes.
Okay.
Now, the fourth graph, just by glance, I see that they are maybe parallel. So the rate is same. So it travels at a constant speed, then takes some rest and start moving again, still away from the starting point, and then again breaks or is at rest. Explain the fifth one.
The fifth one, it's going up at a constant speed, and then
The word away, not up.
it's going away at a constant speed,
Yeah.
and then the speed is increasing,
Then this distance is increasing
distance is increasing, but
at a
this
very high rate. Yes. If it is vertical, I would say that, for example, let's say the speed in this first section, because there are no values, let's say that was 15 that actually jumped. Let's complete the description and then I'll explain any real scenario.
okay. So
Because
yeah,
this section actually shows the same speed.
yeah.
Seems like teleported
So it's just
because there's no change in time. You see, let me say this is 50 and let me say this is 60. So between 50 and 60, this was vertical. This is actually undefined. So I'm using the word teleported. That would definitely not be the part of exam. Vertical lines have gradient which is undefined.
so we're just gonna say it's going up at an unknown speed.
Yeah.
Okay, so it's first traveling at a constant speed, it's going away at a constant speed, and then it's goes up at an unknown speed, and then it continues going at a constant speed.
As that in section 1.
Do
And
we
the last one, yeah, yeah, go on.
we use the word teleported?
I think in this situation that would be acceptable.
Okay. So for what would a real life like example be?
In this case, I cannot think of any one because in no time it is going away.
Okay.
That's why
Maybe
I'm
like a
using
reaction? It
in
can't be.
a fraction, or let's say, let's say that's an explosion.
Okay.
Like it took no time, and the particle just exploded and went away from the mean position. And once it's done, it is still moving with the constant speed.
Okay.
The last section shows negative gradient, and if it is distance time graph, the distance is decreasing, it is coming towards original point, so the object is traveling at a constant speed, coming towards the mean position, and then goes away at a faster rate.
What is the mean position?
Starting point.
Starting point. Okay.
Number 2, the graph shows Anil's daily run. We just discussed this type of graph. Uh,
We drew one, right?
yeah, in the question. So the graph shows Andy's daily run. For how many minutes does he run before he takes rest?
He runs for, so up to that midpoint's 5.5. So that would be 0.2. So 5.2.
See the no. See, these are 5 minutes.
Yep.
5 minutes and 10. So one box represents 0.5 minute. So these
Oh,
are
so
two
it's
boxes.
0. So it's 1. So it's 6.
Yes. So for how many minutes does he run before taking rest? He runs for
6.
6 minutes. Calculate the speed in kilometer per hour at which he runs before taking a rest. How many kilometers is he moving?
He's going 1. 6 minutes. I'm multiplying by 60. Divided by 60. And that's her speed. So 6 to 9. So that would be 4 minutes, 3 minutes. That'd be 6 minutes. Five, and then there's also one extra. So 5.5? Okay, so $10. So 10 boxes in total. So 0.5 times 10. That'd be 5. Okay. So 1,000 meters over 300 seconds. We don't have to round it, right?
Or should I do it quickly with you?
I think we can go over it today, like together.
Okay. This graph shows the movement of a taxi in a traffic during a 4-hour period. So distance is given, time is given. Clearly and concisely describe the taxi's journey. Okay, so the taxi moves with constant speed and covers a distance of 10 kilometers in 50 minutes. And then the taxi is at rest for the next 20, 30, 40, 50 minutes. Then the taxi comes back to the point where it started at constant speed in 20 minutes, stayed there at rest for another 40 minutes, again took off, traveled at a constant speed for a distance of 5 kilometers in 40 minutes, and then at rest till the time 240 for the next 40 minutes.
So we're supposed to like put in the values as well, because I just like said, like described how it was moving. I just said it moves at like a constant speed, then the taxi is at rest, then the taxi comes back with a constant speed, and then it rests. But I also have to add in like how long it's at rest for and how long it's increasing for and the speed for each of them, right?
Yeah, you may have different responses, and your backing statements would support your answer. At the response would have been, see, it is covering 10 kilometers in 50 minutes. So I may say that this is 10 by 50, which is 0.2 kilometer per minute. I may say this. The taxi traveled at 0.2 kilometer per minute for 50 minutes and then stayed at rest for the next 50 minutes, coming back to the original position. Now this is 10 by 20 at 0.5 kilometers per minute and then stayed at rest, and then it took off again away from the mean position, covering a distance of 5 kilometers, which is 5 by in 40 minutes. So I'll have to use this here. 0.125 kilometers per minute and then stayed at rest. So whatever you say, your backing statement supports it. So like any response is acceptable because there's no clarity. He wants us to explain it in terms of speed or just the type of moment. So that's very fine. If you say it traveled with constant speed, then at rest, comes back at constant speed, then at rest, goes away with constant speed, and then again at rest.
Okay, so I just, if the question is asking for it, then that's the only time I would write it.
Yep.
Okay.
B part. For how many minutes was the taxi waiting for passenger in this period? So we have two waiting periods, 50 minutes here, and this is 20, 20, 40, another 40. So in total, we have 50 plus 40 plus 40 is 130 minutes. On other times, the taxi was traveling. So what was the total distance traveled? So taxi traveled 10, then again 10, and then 5. So 10 plus 10 plus 5 is 25 kilometers. Calculate the taxi's average speed during the first 20 minutes. So average speed is total distance over total time. So it is covering 4 kilometers in 20 minutes. So units are important. I'm dealing with kilometers and minutes. So this is 0.2 kilometer per minute. Then it says in the first hour would mean 60 minutes. So you see this is 20, 40, 60. This is 60. And in 60 minutes, the distance traveled is 10. So 10 kilometers by 60. So this is 1 by 6, 0.17 rounded kilometers per minute. Or we can say 10 kilometer, 60 is 1 hour. So you can say 10 kilometer per hour. Third says calculate taxi's average speed from 160 to 210. This is 160, this is 200, and this is 220. So the midpoint is 210. So it is covering 5 kilometers in this time. So 5 kilometers and 210 minus 160 is 50 minutes. So 5 divided by 50 is 0.1 kilometer per minute. And if I wish to change it, 50 divided by 60, so 50 by 60, whatsoever is it, 5 divided by that answer, I'm getting 6. So that is 6 kilometer per hour. And the fourth one is for the full period. So average speed is total distance over total time. We just calculated the total distance, that was 25, and total time is 240. So 240 divided by 60, this is 4 hours. 20 kilometers in 4 hours. So 25 by 4 is 6.25 kilometer per hour. Any doubts?
No.
Number 4. This is a real distance time graph showing distance from the ground against time for a helicopter as it takes off and flies away from an airport. Helicopter motion on takeoff and vertical distance from ground. Make up 5 mathematical questions that can be answered from the graph. Exchange questions with okay. That's group exercise. So we can make different questions. Like I'll put the first one. What was the distance covered? What was the height of the helicopter at time 6 seconds?
These questions will never be asked like in the
Yeah, of
exam,
course
right?
not in the exam, never in the exam. This is just concept building.
Okay.
So one would ask each other for the concept. So let's do a quick exercise. What would be the distance covered in 6 seconds? Yeah, what was the height at 6
It would
seconds?
be 8.
That's 8. Okay. Between what time was the speed maximum?
It was at 10. Oh no. Yeah, it was at 16 and 10. So time 10 seconds.
So max speed will be where it is steepest. Steepest means covering maximum
Oh,
distance in
so
less time.
yeah, so it'd be 4 to 7 seconds.
Okay, 4 to 7. What was the time when the helicopter was just hovering over?
It would be 8 to 9. No, no, no. 7 to 8.
That's right. It is at 2 seconds, and then it is at 7 seconds, and at 8 seconds again. Wherever I see that I draw the tangent and I get a horizontal line, I'm answering those values because the speed is zero, the movement is zero, it is just standing there. I'm not answering at 4 because I know that at that point it is touching the ground.
It's not above the ground. Okay.
Okay, so these were distance time graphs, and the next exercise is about speed time graph. So, quick recap of distance time. It gives us the distance, it gives us the time, and the gradient gives us the speed. Now, when we are talking about speed time graph, it would give us speed, time, and the gradient will give you the acceleration, and the area under the curve will give you the distance. Obviously, speed time graph is going to give you speed and time, but the gradient will give you acceleration, and area under the graph will give you distance. So in certain cases, speed or velocity of an object may change. In increase in speed is called acceleration. A decrease in speed is called deceleration. Are you familiar with these terms, acceleration and deceleration?
Yes.
Okay. A speed time graph shows speed rather than distance on the vertical axis. This graph shows the train's journey between two stations. So the train starts at zero speed. The speed increases steadily, reaching 18 meters per second after 15 seconds. The train travels at a constant speed horizontal section A to B of 18 meters per second for 25 seconds. The train then slows down at a steady rate till it stops. The entire journey took 60 seconds. Now, just by looking at the graph, I can see that the acceleration is more than the retardation. Acceleration is from 0 to A, retardation is from B to C, because it accelerates in lesser time from 0 to 18, whereas it stops in more time from 18 to 0. So the speed increases by 18 meters per second in 15 seconds. So gradient is change in y over change in x, 18 by 15. So it is giving me 1.2 meters per second every second. So that's the acceleration, 1.2 meter per second square, the gradient of the first section. For speed time graph, the gradient is acceleration. Positive gradient means acceleration. Negative gradient means deceleration. Distance traveled in speed time graph. We already know that the distance is speed multiplied with time. Formula S equals Vt. On speed time graph, this is represented by area of the shapes under the section. You can use the graph to work out the distance traveled. One of the worked example, the speed time graph represents the motion of a particular particle over a period of 5 seconds. During which periods of time was the particle accelerating? So where the gradient is positive and the speed is increasing, it is accelerating from 0 to A, and then B to C. B part says calculate the particle's acceleration 3 seconds after the start. So this is time 3 seconds. So basically it's talking about this section. So I'm going to find gradient of this section. So I see y is 25 at C, y2 minus y is 15 at B over time taken. So at C the time is 3.5 and at B the time is 2. So there's a change of 10 in 1.5.
So 25 minus 15.
Yes,
The point, yeah. So
using these coordinates, C is x 3.5
25.
and y 25, and this B is x2 y 15.
Oh, okay, so y2 minus y1 over x2 minus x1.
Yes. So 6.7 meters per second square. C part says calculate the distance traveled by the particle in 5 seconds. So distance traveled is area under the graph. Now you may choose how many sections you want to solve. If I see the section made by book, this is one triangle, rectangle, another triangle, and another rectangle. We may choose our own. So I'll just split it into two. One is this one large section known as trapezium, and the other is this section again a trapezium. Do you remember how we can find the area of trapezium?
1/2 side 1 plus side 2 times height.
Very good. So side one, I'm talking about this large trapezium. So this is 5 plus. Now this horizontal section, this starts at, you read it. This is 5, 6, 7, 8 boxes. So this is 0.8. So zero point 0.8 less than 5 is 4.2. Would you agree that this straight base is 4.2 and the height is 15 plus the trapezium at the top is 1 by 2 times base from 2 to 5 is 3 and from 3 to 3.5 to 5 CD is 1.5.
So it's
And
just the point at A subtracted by the point at S, basically.
yes,
I mean, point at P subtracted by S for 4.2.
yes. So I'm using calculator to work out 4.2 plus 5 divided by 2 times 15 is 69. And the second section is 3 plus 1.5 divided by 2 times 10 is 22.5. Getting 69 plus 22.5, which is 91.5.
And then do we divide the total value by 2?
Yeah, already just punched in the calculator.
So for total trapezium,
Yep.
is the formula for half 1/2 side 1 plus side 2 times height, or is that the formula for a total one?
This is the total trapezium 1 by 2 side 1 plus side 2 and times the height. Height is the distance between the
Yeah.
parallel lines.
So the other side doesn't have to be like slanted as well. Only one side can be slanted.
Yeah, that's what the trapezium is. If the two slants are equal in this way, this is a parallelogram and this would be
No,
just
I
base.
mean the other way. I mean the other way. If it's slanted the other way.
No issues, even if it's inwards or outwards. One shape, second shape, third shape. Anyway, the
Okay.
point is four sides and one pair of parallel side is a trapezium.
Okay.
We may have two different slanting, like this is one line and this is like more steeper. Still, four sides and one pair of parallel side.
Okay, I see.
Obviously, the units are important. When calculating acceleration, the distance traveled from a speed time graph is essential, and the unit of speed on the vertical axis involves the same unit of time as on horizontal axis. In the example above, the speed unit was meter per second and the horizontal was seconds. So units were compatible. Either we write kilometers per hour or meters per second, And in this worked example, as we can see, this is kilometer and minutes. So we'll just mention it that it is kilometers per minute. But the compatible units are meters per second and kilometer per hour. The diagram above is a distance time graph for short car journey. The greatest speed reached was 60 kilometers per hour. The acceleration in the first 2 minutes and the deceleration in the last 2 minutes are constant. Draw the speed time graph of the journey. Calculate the average speed in kilometers per hour for the journey. Okay. So if we see the graph, this is from 0 to 2. I can see increasing gradient. That means increasing speed. And then I can see decreasing gradient. That means decreasing speed. Can you see these two clearly?
Yep.
So this maximum speed is given. In this section, actually, we were unable to find the exact magnitude because of lesser data given. Data is not sufficient. I may draw tangents, but I do know that the gradient is increasing. And how much is it? Maximum speed is 60. I'll just copy it here. So constant increase, and in 2 minutes, and the speed is 60 kilometers per hour. And then there's constant retardation, so it ends at 4. And this is the reflection from distance time to speed time. You need to understand that gradient of distance time gives you speed. So gradient is increasing. See, the speed is increasing. And then the gradient is decreasing. The speed is decreasing. Gradient is horizontal at the start. That means a 0. Gradient is 0. Speed is 0 at start. It is horizontal at the end. Gradient is 0. So the speed is 0 at the end. And it says calculate the average speed. So average speed is total distance. Total distance is 2. Total distance divided by total time. Kilometer and minute. So that's a 0.5 kilometers per minute. If we wish to change the units, we can. 4 divided by 60 in hours is 1 by 15. And 2 divided by answer is 30. So that would be 30 kilometer per hour. Practice exercise. The distance time graph represents Ibrahim's journey from home to school one morning. Distance time is given a to b, constant gradient, increasing speed. Gradient gives me the speed, so gradient is constant, constant speed. B, C, gradient is 0. At rest, C, D, again, constant speed. A part says how far was Ibrahim from home at 8:30. So we reach the point 8:30. We use the graph, and this is midway between 1, 2, and 2.5. So this is 1500 meters. At 8:30, he was 1500 meters away from home. B part says how fast in meters per second was Ibrahim traveling during the first 10 minutes. So 8 to 8 to 10. He just covered, okay, these were 5 boxes, so 200 meter per box. So he covered 1200 meters in 10 minutes, and the examiner needs it in meters per second. This is already meters, so I'm changing this into seconds. So that would be 1200 by 600. So he's covering 2 meters per second. C part says describe the stage of Ibrahim's journey represented by the line BC. So BC, no distance covered, time is passing. So he is at rest. D part. How fast in meters per second was Ibrahim traveling during the last 20 minutes? So this is 40, this is 20. Is talking about section CD. So in last 20 minutes, he's covering three of these boxes. One box was 200, so he's covering 600 meters in 20 minutes. Now, and again, meters per second. So this is 600 meters, 20 into 60. 600 by 20 into 60 is giving me 0.5 meters per second. Any doubt in this question?
No.
Let's try number 2. That is speed time graph. The graph below shows the speed time in meters per second of a car as it comes to rest from speed of 10 meters per second. Calculate the rate at which the car is slowing down during the first 3 seconds. Can you do that? Doing it? A part done?
Oh, but I'm about to finish.
Okay.
Is A part -2 meters per second?
Meter per second square. Now, this sign would depend. Calculate the rate at which the car is slowing down. He's already saying slowing down. So 2 meters per second square would be sufficient. Basically, slowing down is retardation. The gradient of this graph gives acceleration. If I'm writing acceleration, I'll write -2 meters per second square. If I'm writing deceleration, I'll write 2 meters per second square. So the word is just complementing it already, that it is slowing down at a rate of 2 meters per second square.
Okay,
And
so
B
we just
part,
answered 2. Okay.
distance in B part, 35 meters. Are you getting this distance?
For B part?
Yeah. Calculate the distance traveled in first 10 seconds.
So one part is trapezium and another part is triangle.
Yeah, that is your choice, whatever split you make. I
Yeah.
made this split. One may draw it any way. You may make this trapezium and that triangle. So that's your choice. But we end up at same answer. C part says calculate the average speed of the car in the first 10 seconds. So average speed is total distance over total time. That is 3.5 meters per second. Shall I move?
Yes.
Okay. Number 3, again, speed time graph. The diagram below is a speed time graph of a car's journey. Calculate the acceleration during the first 20 seconds of the journey. Acceleration is given by gradient. In the first 20 seconds, I see that there's a change of 20 by 20. So rise over run is 1 meter per second square. B part says calculate the distance traveled in the last 10 seconds of the journey. So last 10 seconds, area under the graph, 1 by 2 into base into height, 100 meters. C part says calculate the average. Sorry,
So for the last 10 seconds, we would calculate the. So we're calculating the whole distance, right?
distance traveled in the last 10 seconds. So I just took the area of last 10 seconds.
Okay.
Now calculate the average speed of the whole journey. For this, I'll need the whole distance, total distance over total time. So my first section, I'm taking that as trapezium 1 by 2, sum of parallel sides. This is 50 plus the top horizontal section 20 to 50 is 30. And the height is already 20. So and the last section was 100 meters. So this is 50, 30, 80. 18 to 10 is 800 plus 100. That's 900 meters. So average speed is total distance divided by total time. 15 meters per second. Clear?
Yes.
Next topic, proportion. In mathematics, the proportion is an equation or relationship between two ratios. In general, A ratio B is equal to C ratio D. Quantities are said to increase or decrease in proportion if multiplying or dividing quantities by a value results in multiplying or dividing the other quantity by the same value. In other words, there is a constant ratio between the corresponding elements of two sets. So, for example, if I just say this is 1:2 and I make this as 10, so that will be 20, increased both by 10 times. So direct proportion is in which both the quantities are increasing. Inverse would be one is increasing, the other is decreasing. So when two quantities are in direct proportion, they increase or decrease at the same rate. In other words, the ratio of the quantities is equivalent. If there is an increase or decrease in one quantity, then the other will increase or decrease in the same proportion. So they are directly related to each other. Here are some examples of quantities that are in direct proportion. Now, speed and distance covered. So this speed is in kilometers per hour. So zero speed, zero distance covered. If speed says 45 kilometers per hour, so 45 kilometers are covered and so on. Speed is increasing, rate, the distance covered is also increasing per unit time. Distance is speed into time. So faster you drive in a set time or per unit time, you get the distance, more distance covered. So number of items and mass. So there's no item, there's no mass, 0, 0. Now if one item weighs 2, I'm doubling the items, see the mass is doubled. When you triple the items, see the mass also triples. When you increase the items 4 times, the mass also increases 4 times. So they are directly proportional. If one item has mass of 2 kg and two items, same item will have mass of 4 kg and so on. Third example, number of worked hours worked. So we can also say that they are getting $12 per hour. $12 per hour. So definitely with 2, it is 24 and 3, it is 36. So again, directly proportional. Number of hours are increasing, the amount is increasing. Graph of directly proportional relationships look like this. There are two things in it. One is it is a straight line and the other is it passes through 0. If you have any graph looking like this, which is a straight line but not passing through 0, so that is just linear. It is just a linear graph. To be directly proportional, it has to pass through 0. So this is a graph for conversion between rupees and dollars. I can't find, yeah, found a perfect spot. So this tells me that 8 US dollars is equivalent to, this is 100 divided by 5. So one small box is 20. So that is 360. That is equivalent to 360 rupees. So I'm just working out what is it for $1. So $1 is equals to rupees 45, which was not easy to read from this point. I was not sure where it would end. So I just chose a point where it crosses the perfect lines. Practice exercise of the concept. Which of these could be examples of direct proportion? The length of side of square and its area. Is it direct proportion or not?
I think, yeah, it is because it's just squaring it.
Now see, if I say square is of side 1, area is 1. If I say square is of side 2, area is 4. If I say square is of side 3, area is 9. You see, you double the length, the area is not doubling. You
Oh,
triple the length, the area is not 3 times.
okay.
So could be example of direct proportion? No. The age and height of students. Now that could be objectional. Like
Yeah.
we may have like like if I talk about a specific country or region, so we may have like in initial years the age is increasing and the height is increasing, but More or less, I would say no, because a child who's 1 years and then 2 years, the age is actually doubled, but the height may not be double. He may have like increased from this much to this much in 1 year, but is not doubling in number. The amount of money collected in a sponsor walk if you are paid $5 per kilometer. This is a yes, because with every kilometer you're getting $5. The distance doubles, the amount paid doubles. Getting it?
Yes.
D part. The time it takes to cover different distances at same speed. So speed is
Yes.
constant. Yes. So if distance is more, time would be more. Yes. Height of objects and the length of their shadow.
Yes.
Good. The amount of petrol used to travel different distances.
I mean, yes, it is strictly correlating, but it may not be like,
In this scenario, if you travel like double distance, double fuel will be used.
yeah.
Irrespective of the, like, we would just consider that other aspects are constant. For example, the road is horizontal, the drivers are pressing the accelerator at the same rate. G part. Number of chickens you could feed with 20 kg of feed.
Yes.
The height of tree and the number of years since it was planted.
No.
No, these two resemble each other. The area of sector of a circle and angle at the center.
Angle. Oh. Yeah, it does.
Yes, because the formula is angle over 360 into pi r square. Everything else is constant, so if we just double the angle, area would be doubled. Unitary method is just cross multiplying or converting it into one unit first. For example, I just tell you that I bought 5 t-shirts for $700. So you can always change it into unit price. So 700 divided by 5, one t-shirt is $140. Now you know for 1 unit, and anything could be answered using this. So that's the unitary method. Normally we do not go for 1 unit, we just cross multiply and the question handles itself very nicely. 5 bottles of perfume cost $200. What would 11 bottles cost? Let's just compare here. 5 bottles are already costing 200. So 200 by 5 is $40 per bottle. That is for 1 unit. So 40 times 11 is 440. And what do we do in unitary method is $200 for 5, so X dollars for 11. So we just cross multiply. That is 200 into 11 by 5. That is exactly the same thing. But we're doing it in one step. 200 by 5 into 11. No change. This again results in $440. The same problem can be solved using a ratio method, which we just did. 200 ratio 5 and X ratio 11. And if you can see the difference, that's just the writing style. I wrote 200 and ratio 5. He's writing 5 by 200.
It's
So
the
you
same
just,
thing.
yeah, that's the same thing.
Yeah.
4 soft drinks cost $9. How much would you pay for 3? I'm calculating will match the answer.
$6.75.
Correct. 9 by 4 for 1 into 3 is 6.75. A car travels 30 kilometers in 40 minutes. How long would it take to travel 45 kilometers at the same speed? So 30 kilometer in 40 minutes, 45 in X minutes. So I am getting 60 minutes. Do you get the same?
I'm just checking. $60.
Number 3. If a clock gains 20 seconds in 4 days, how much does it gain in 2 weeks? 20 seconds in 4 days. So how much does it gain? It gains X in 2 weeks. 2 weeks are 14 days.
70.
70. 6 identical drums of oil weigh 90. 6 weigh 90. How much would 11.5 drums weigh?
$172.5.
Correct. 172.5 kgs. An athlete runs 4.5 kilometers in 15 minutes. How far could he run in 35 minutes?
$10.5.
Correct. 10.5 kilometers. To make 12 muffins, you need 240 gram of flour, 48 gram sultans, 60 gram margarine, 74 ml of milk, 24 gram of sugar, 12 gram of salt. How much of each ingredient would you need to make 16 muffins? I'm just going to calculate 1 unit for all and then multiply. This is 12, this is 16. I'm just looking at what is the increase in ratio. This is 16 by 12. And that is 4 by 3 or 1.33 reoccurring. So I'm multiplying everything with 4 by 3. So 240 into 4 by 3. 4 by 3 into 240. So that would be 320. And then 4 by 3 into 48. is 64 into 60 is 80 grams into 74 is in decimals 98.7 ml, and then 24 is 32 grams, and then 12 is 16 grams. Express the amount of flour to margarine in the recipe as ratio. So flour is 240 and margarine is 60. Flour to margarine. So 24 is to 6, 6 one times, 6 4 times. So flour to margarine is 4:1. Any doubt?
So it'd just be 240 to 60 and then simplified.
Yes.
Okay.
Question number 7. A vendor sells frozen yogurt in 250 grams and 100-gram tubs. It costs 1.75 for 250 and 80 cents for 100 gram. Which is better buy? Can you handle this question?
Yes, I think so. The first option,
That's right.
250 grams.
That's right. I did it in this way: 250 by 1.75. That was mass per dollar. So I was getting 142 gram per dollar. And in the second option, by 0.8, I'm getting 125 gram per dollar. So this is more mass per dollar. So the first buy.
I just did the proportion of 80 over 100 and then x over 250 to see how much it would be to like build up to 250 from 100 grams, like from 80 cents. How
That's
much it
fine.
costs.
That's acceptable. That is a different approach. That's right. Question number 8. A car used 45 liters of fuel to travel 495 kilometers. 45 liters, 495 kilometers. I'm just checking 495 by 45 and I'm getting an exact answer. That is 11 kilometers per liter. Let's see. How far could the car travel on 50 liters? So in 1 liter, it is 11. So 15 to 11. Or cross multiplication, anything. So 550 kilometers on 50 liters. How much fuel would the car use to travel 190 kilometers? 190 by 11 is giving me 17.27 repetitive liters. Could use this much fuel for 190 kilometers. Or we could just use unitary method and ratio method. 45 ratio 495 and then 50 ratio x. And same for the second part. Question number 9. The graph shows directly proportional relationship between length and meters. The length in feet, okay, metric unit, and so conversion between feet and meters. Use the graph to estimate how many feet there are in 4 meters. Can you read the graph?
Yes.
You want me to zoom in?
Yeah, just a little bit. Thank you. 13?
That's correct. So 4 meters represent 13 feet. Given that 1 meter is equals to 3.28 feet and 1 foot is equals to 0.305 meters, calculate how many feet are there in 4 meters. So from the graph, we are getting 13. And by calculation, we are getting 13.12. Okay, which is longer, 4 meters or 12 feet? You already know that 4 meters is 13.12 feet. So 4 meters is longer. 20 feet or 6.5 meters. I'm converting this 20 using this given ratio. 1 feet was 0.305. So 0.305 times the 20. I'm getting 6.1. So 6.5 meters is longer. Mr. Bocomo has a length of fabric 9 meter long. What is the length to the nearest foot? What are you getting?
So 9 times 0.305?
9 times 3.28. We're converting meter to foot.
29.52. So we have to multiply it with the feet. Okay.
Yeah. 1 meter was 3.28, so 9 meter is this much. And to nearest foot, we just round off. He cuts and sells 1.5 meter to Miss Jonas and 3 feet to Mr. Musa. How much is left in meters? So already he had 9 minus 1.5 and 3 feet minus 3 into 0.305. Six 6.585 is left in meters. Any doubt?
We're just subtracting the total
Yeah.
with how much he cuts and sells, and then
We just
we,
had to take care of 3 feet.
yeah, 3 feet to meters.
Yes. A driveway was 18 feet long. It was resurfaced and extended to be 1 meter longer than previously. How long is the newly resurfaced driveway in meters?
$59.04. No.
In meters.
So we multiply the 18 with the 3.28, right?
No.
Oh no, we multiply with 0.305.
No again. This is already 18 feet. So we divide it by 3.28 to get it into meters. So the driver was 18 feet already. So 18 by 3.28 is meters. It was resurfaced and extended to be 1 meter longer. So this is the new length.
So feet and foot are different.
Feet and foot are same, but meters is different.
So when it's feet and we're asking for meters, we have to divide it.
Foot is actually one. Feet is the plural word for foot.
Okay.
See this one at top, 1 meter is equals to 3.28 feet.
Okay.
So 1 meter is equals to 3.28 feet. Now this is 18 feet already, so this is x. When you solve for x, it is 18 over 3.28. To convert it into meters, you're dividing feet by 3.28.
And then add 1.
And then add 1 because it is 1 longer. So I'm getting 6.487 or approximately equal to 6.5 meters. Okay, I'll share the test shortly. We've covered 2 topics. And inshallah, we'll go with the next topic in next class.
Okay.
Inverse, direct and inverse algebraic form, one topic. Increasing, decreasing. So more or less 2 exercises, no issues. So we did this. We were, I guess, on speed time. Okay, we were on proportions. Okay, inverse proportion. In inverse proportion, one quantity decreases in the same proportion as the other quantity increases. For example, if work is to be done, it can be done in less time if more people help. As the number of people who are working increases, the time it takes to get the job done decreases. The graph of inversely proportional relationship is hyperbolic. Indirectly proportional, it should be straight line and pass through zero. If it is not passing through zero, the relation is only linear but not directly proportional. One worked example: a person traveling at 30 kilometers per hour takes 24 minutes to get home from work. How long would it take him if he traveled 36 kilometers per hour? Now, see, the speed is increasing, so the time should reduce. First, it was 30 kilometers and taking 24 minutes. So I'm using this is distance in kilometers and this is time in minutes. Time in minutes 24. Now the speed is 36. Time should be x. We know the speed is increasing, the time should reduce. So we multiply them this way. We do not cross multiply. So 30x is equals to 24 into, sorry, 30 into 24. We do not cross multiply. 30 into 24 equals 36x. So x is equals to 30 into 24 divided by 36. And we get 20 minutes. In this very question, one option would have been finding the distance and then solving again. But we could just directly do it. A woman working 6 hours per day can complete a job in 4 days. How many hours per day would she need if to need to complete the job in 3 days? So we are requesting her to complete the job earlier, so she'll have to work more hours. So 6 hours, she's taking 4 days. Hours and days. Now we need to complete it in 3 hours, 3 days, so unknown hours. This needs to increase because days are reducing. So again, 6 into 4 is equal to x into 3. Indirectly proportional, we cross multiply, and in inversely proportional, we multiply them this way. So 6 4 times 24 by 3 is equal to x. X is equal to 8 days, 8 hours per day. Question 1.
So how do we know what questions we do inverse proportion and what questions we do normal proportion for?
The question, reading this statement, when we get the understanding that both the quantities will increase. For example, if I say we are buying some products and we double the amount, the quantity, so the price will double. Both are increasing. So if one increases, the other decreases is inverse proportion. As question number 1 says, 30 kilometers, a person is traveling at 30 kilometers and it takes them 24 minutes. And in second half of the question, it says the speed is increasing. So if we increase the speed, definitely we will take less time. So one is increasing, the other quantity is decreasing.
So one increase, one decrease will make it inverse?
Yes.
Okay.
Both increase direct, both decrease direct. A hurricane disaster center has a certain amount of clean water. The length of time the water will last depends on the number of people who come to the center. Before going into detail, the water would last. They're using up the water. So if there are more people, what will happen? More days or less days? If more people come to the center, will the water last more days or less days?
Less.
Less. So that's inverse proportion. So it says calculate the missing values. Now we can do unitary method for all of these, or we can just find out the equation of inverse proportion. Both are possible. I'll show you both ways. If I say 120 and 40, this is number of people, this is number of days. I'm making this set for 1. For example, 200 people and x. So 200 x is equals to 120 into 40. X is equals to 120 into 40 over 200. When you look at the table and what we just did, we're going to change 200 each time. So numerator stays same and we keep on changing the denominator for our answers. So numerator is 120 into 40 divided by 200. When I'm dividing by 200, I'm getting 24. Now changing the denominator to 300, I'm getting 16. Changing the denominator to 400, I'm getting 12. That was one method. The other method would have been, let's say number of people are inversely proportional to days. P is equal to Q over D. I'm going to use one set of given value, any value. We could also use 150 and 32. So number of people 120, K number of days 40. So K is equals to 120 into 40, getting 4800. I'm going to rewrite the equation. So number of people is equals to 4800 over number of days. Now we can use this equation and adjust it accordingly. Here all the number of people are given and days is missing. So I'm rearranging it. So days is equal to 4800 over number of people. Now you just keep on replacing number of people. See, it was no different because the numerator here is still 4800 and the denominator, which is number of people, keep on changing and we get the answer.
Could this be done with the rate of change?
Yeah, that could be done. If it is given, it is a linear, and in this case, yes.
Okay. And we could also just like find out like 40 to 32, that's minus 8, and then we could follow the trend only if it's linear, right?
Yes, but you also see that number of people, that's 120 and then 50. See, the change was of 30 people. And then from 150 to 200 is 50. Now that's 100 and that's 100.
Oh, I see. So because because the top part is not linear as well. Okay.
Basically, if I give you that this is the trend, but unfortunately, sometimes I'm asking it 1, what is the value? Then I'm asking it 2, what is the value? And I'm asking it 3, what is the value? And suddenly what I say at 7. So the gap basically changes. As you can see, 30, 50, 100, the gap is basically changing. So we just build up one relation, that is product of which two is equal to product of other two, or we just write the equation. It is always helpful, or else in every question we would be thinking about the relationship between them. Like,
So
is it
product of which two equals to
any two, any
any
given two?
two? Okay, product of any two equals
Yeah.
to
Say 120 and 40 were given.
yeah.
We could have chosen 150 and 32. Just see what the product is of 150 and 32. Not using calculator?
I have a calculator.
See the product of 150 and 32. You'll get the same answer as of 20 and 40. 120 and 40.
So product of 150 and 32, right?
Yeah,
4800.
4800. So basically the relation, because it was constant, so it just continues. So we can either use the unitary method on the left hand side or use the equation method on right hand side. They are exactly same if you look them closely. On left hand side, we are multiplying 120 and 40. On right hand side, we did the same to find k. Once k is 4800, on left hand side, see 120 into 40 on numerator, that is not changing. We just keep on changing the denominator, which is the exact same thing happening in the equation.
The top part doesn't change, the bottom part does, the denominator.
Yes, because the relationship is constant throughout. Let's try number 2. It takes 6 people 12 days to paint a building. And now the difference in question 1 and 2. There were 5 different values in question 1. So we may think of constructing an equation. But in question 2, there's only one case, so no specific need. It takes 6 people 12 days to paint a building. Work out how long would it take the same rate using 9 people. So see, from 6 to 9 people, I'm expecting that people are increasing, so number of days would decrease. So my initial attempt is 6 into 12 on the other side, 9 into unknown. 6 people 12 days, 9 people x days. I just cross multiplied it. I need to rearrange. Number of people, number of days. 6 people take 12 days, 9 people will take x days. So 6 into 12 equal to 9 into x. 6 into 12 is 72. By 9, we're getting 8 days. So they were doing in 12 days. Now they are going to do it in 8 days. Now people are increasing to 36. So same, using these two same, but changing this 9 with 36. Y is equal to 6 into 12 stays there, and denominator is 36.
2.
So 2. It takes them 2 days. Question number 3. Sanjay has a 50-meter long piece of rope. How many pieces can he cut it into if the length of each piece is 50 centimeters? Can you do that? Trying this?
Yes. $100 for A.
That's correct.
$25 for B.
Correct.
And then 8 for C.
Correct. D part. He cuts the rope into 20 equal lengths. What is the length of each piece?
250.
Correct. An Airbus usually flies from Mumbai to London in 11 hours at an average speed of 920. During some bad weather, the trip took 14 hours. What was the average speed? So it is pretty obvious it is taking more time, so the speed should be less. I'm getting 722.8.
7.
11.
Yeah.
You're getting same?
722.8, right?
Yes.
Okay.
If I just round off, that would be 9. Number 5. A journey takes 3 hours when you travel at 60 kilometers an hour. So how long would it take if we decrease the speed to 50?
3.6.
3.6 hours is correct. Okay, now 2.16 direct and inverse proportion in algebraic terms is going to be this thing on the right, which we did for question number 1. That is equation making. So whenever we have direct proportion, we definitely write the two variables in front of each other. Whenever you have inverse proportion, one goes in denominator. For example, I say y is directly proportional to x. So you write it like this. Then equation is y equals kx. When I say y is inversely proportional, we write it like this. And equation goes this way. K is always in front of y, and direct and inverse would decide if both the elements are in front of each other or one of them is in the denominator. It could
K,
be other.
sorry, K is the constant rate of change, right?
Yes.
Okay.
Now it depends if that is not linear. You would say that y is directly proportional to x square, or he would say it is inversely proportional to x square. So in case of inverse, it comes in denominator. In case of direct, it stays in front of it. So y is directly proportional to x cube. It stays in front of it. And you'll always have one set of value. In this case, x is 2 when y is 32. So write the equation y is directly proportional to x cube. Y is equal to kx cube. We have first set of value, so that x2 and y32. In place of y, in place of x. 2 cube is 8. 32 by 8 is k is equals to 4. So when k is 4, we can rewrite the equation y is equals to 4x cube. Now whatever he asks, he's saying find the value of y when x is 5. So 4 into 5 cube, 125 into 4 is 500. Now it could be anything. He may give you value of y and then find x, or value of x and then find y. Second work example, f is inversely proportional to d square, and when d is equal to 3 and 12, so set of values given inversely. Important thing, inversely, so it goes in the denominator. K always remains in front of the first variable. So when d is 3, f is 12, we just substitute d d3 and f12. 3 square is 9, 9 into 12 is 108. So value of k is now 108. My final equation is 108 by d square. So whatever the examiner says, just like d is equals to 4, we just substitute. So 108 by 16 is giving me 6.75. Some corresponding values of the variable P and Q are
Wait,
shown
sorry,
in.
can you go over the inverse one again?
Yeah, sure.
With the equation for it?
I'll write it. So it says inverse f and d square. So this goes inverse. Then when we write the equality sign equation, we introduce the constant. So it is in the denominator because of the word inverse. It is not in front of f. If d would increase, f would definitely decrease because d is in denominator. Now we always have one set of value, known value, where 12 is f and d is 3. So 3 square is 9, 9 into 12 is 108. Once done, we always rewrite the equation 108 over d square. Now we have the equation, whatever is given, we may find the next value. So d4 is given. So the f is inversely proportional 108 over 4. So 108 by 16 is 6.75.
So
Clear?
first we plug in the d with a 3, and then we move it to the other side. Then we get k equals 108.
Yes.
And then we do f equals 108 over d squared. And then we put in the 4.
Yes.
Okay.
23. Some of the corresponding values of variable P and Q are shown in the table. Are P and Q directly proportional? Now he's just asking if they are direct or inverse. I'm looking at 2.8. So when I go from 2.8 to 7, value is increasing, Q is also increasing. Then 7 to 11.2, Q is again increasing. So yes, they are directly proportional. But I need to be sure, definitely they are increasing, but I need to be sure they're directly proportional. Are they straight line? So this gap is 3, this gap is 3, this gap is 4. So in case of direct proportion, I need to check if P is directly proportional to Q, so it should be P is equal to KQ. K is the constant. P divided by Q should give me the constant. What do you expect the constant to be same or changing?
I expect it to be different, changing.
When it is K is the constant. P and Q would change. K is always constant.
Okay. So the
Like
change
we
though is constant.
did this, K was 4800 and it is not changing. Even we find it from 120 and 40 or we find it from 150 or 32. The constant stays same. Variables, they change.
Okay.
So how do we get K? We get K by P divided by Q. So I'm checking the first one, 2.8 by 2, and I'm getting 1.4. Now the second one, 7 by 5, again 1 by 1.4. Third one, 11.2 by 8, same answer, 1.4. 16.8 by 12, same answer, 1.4. So yes, they are directly proportional because we are getting same constant every time.
So the change is always constant. And we check that by seeing what is like the difference between the increasing values.
Yeah, we can do that. I actually started checking off that, but I stopped because this was 3, this was 3, and this is 4. Now I'll have to check the proportion that it is in proportion to these. That would increase my task. So easy way was to construct the equation and see. Like the same example, this line is directly proportional, yes. So at 2, some value. At 5, some value. At 8, some value. This gap was same. Now the gap is changing. So that was just may introduce more calculations. So easy task is if he's claiming that it is directly proportional, so we just write P is directly proportional to Q, and the constant is P divided by Q. Not clear?
So it says P and Q are directly proportionate. So it is going to be P equals to KQ. And
Yes.
then we can just rearrange it as P over Q equals to K. And
Yes.
then,
That was his claim.
yes.
Wrote the equation for ourselves. P over Q is equal to K. Now we're checking if his claim is true or not. So for all these values, P over Q is same. That is 7 by 5. That is 1.4. So his claim was right. Yes, this is directly proportional.
Oh, so we have to just do, like, for example, 2.8 over 2. And if that's the same as 7 over 5, then it's directly proportional.
Yes.
Okay. So it would be 1.4 for all of them, right?
Yeah. Why are we checking? For example, I just say this is 30 and the other value is, let's say, 25. So you see P, am I still increasing?
Yeah, it's increasing.
Check Q. Is it still increasing?
Yes.
Now check the last value 30 by 25. That is P and 25 is Q. Now I'm getting 1.2.
Are you writing something? You're frozen, I think.
No, wrote nothing.
Okay.
So 30 by 25 is 1.2. Can we check that?
So 30 by 25,
Yeah,
1.2, yes.
1.2. Because the gap was not constant, so I couldn't comprehend it without writing. If the gap would have been constant, then no issues. We could just comprehend it by reading that 3 unit is increasing in Q and 7 minus 2.8. We could have said that 4.2 is increasing in P. So yes, constant increase, constant decrease, yes. But in this case, it was not constant, so I had to check. The cohesion form is the best form. Because still, with 30 and 25, we can see they're increasing. But is the increase proportional? So that was no. So that's why we always check.
The increase is not proportional. So
When I
what?
30 and 25, when I wrote 30 and 25, then it is not proportional. So this claim would be wrong because it wouldn't be a straight line. The increase would be this way. See this curve. Still, both x and y are increasing. Would you agree?
Yes.
But they're not proportional. It
Then
keeps
why
on.
did we write yes? So what is proportional?
We did this table. We checked this table. That was yes. But why are we checking them by dividing? To see if they are in exact proportion. Because this increasing value is not the measure. We cannot just straight away say. Because if even one value differentiates, we will not get 1.4, then we'll write no.
Oh, because all of them are 1.4, we write yes.
Yes.
Well, when it's 30 and 25,
Then we would have written no. Because we will be getting different k. K is always same. Either it is direct or inverse. K is always same.
so it's not 30 and 25?
With this table right now on screen, the answer is yes. With 30 and 25, the answer is no. Why is that no? Because with 30 and 25, I'm getting k as 1.2, whereas with all these values, I'm getting k as 1.4. We always have to check. We cannot just say that yes, p is increasing throughout and q is increasing throughout, because the
So
rate may be same, the rate may be different.
we got 30 and 25 out of the table, and then because we divided them each other and didn't get. Oh, so if it was a continuation, then it would not be. But
Yes.
since all of them are 1.4, then yes.
Yes.
Okay.
Compare each pair done. We did the exact same working. Worked example 24. 3, 4, 5, 6, 12. Copy and complete the table of values for y directly proportional and inversely proportional. So doing it for directly first. Y is directly proportional to x. So y is equals to kx. Now I need to find k. When y is 12, x is 3. So k is equal to 4. So my equation is y is equal to 4x. I just need to substitute in x. So when I substitute 4, I get 16. When I substitute 5, I get 20. And when I substitute 6, I get 24. Getting it?
Yes.
In this case, I could have done it without equation. How? Because these gaps are constant. These were all 1, 1. So these gap will also stay same. See, 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. In the
So in the
previous question, the gap was not same. So to be sure, I had to use the equation. Or I would have just checked the gaps and said, yes, the gap was actually changing.
so because the top gaps are not changing, then
Then bottom gap will also not change.
okay.
Now we
But
check for
still,
inverse relation.
but it's still directly proportionate, right?
Yes, it is still directly proportional.
So there's two different type of ways for it to be directly proportionate. So it can either be like when we
There's
divide it.
there's no different way. Way is same. It depends on the values. Examiner was giving us these values C2, 5, 8, 12. The gap was not constant. That is why we checked the equation. If the gap would have been constant, there's no need. For example, 2, 4, 6, 8, 10. Is the gap changing?
No.
No. So if I just write 6, 12, 18, 24, 30, is the gap changing?
No.
No. So this is directly proportional.
So because so it can either be, so we first have to check if the gaps are changing, and then if they are, then it is. We don't have to do the equation, but if they're not, then we have to do the equation.
In green numbers, constant increase, yes or no?
Yeah, it is.
In blue numbers, constant increase.
Yes.
Both increasing, both constant, and no confusion. But if the table would have been like this, 14, or let's say it would have been 17. Now the gap is not same. It may confuse me. I will go for a check. Now what is that check? I'm just dividing this number with this number. 6 divided by 2. I'm getting 3. Now I will make this check. 12 by 4 is 3. 18 by 6 is 3. 24 by 8 is 3. 30 by 10 is 3. 51 by 17 is 3. And why are we dividing? Because in direct proportion, y is equal to kx. Y divided by x is k. That is why I'm dividing. And checking if I'm getting the same constant every time and I get 3 every time. So that's again a yes. That depends on type of data, that it would be okay by just having a look on it, or we literally need to solve. If these numbers would have been decimals, maybe, then again we'll have to solve.
When we have to write our working, do we have to do the equation, or can we just say, let's say, the gaps are equal? Can we just say the gaps are
We can
equal?
say
That's why it's directly proportionate.
that this sentence structure would matter. If we can give the explanation nicely in words, that is acceptable. Best part is always the equation.
So, what would be
Like,
like a good sentence example if the
eh,
gaps
like,
are equal?
like the one example here, I can say the change in x, the increase in x is 1 unit, and the corresponding increase in y is 4 units in all values. So that would be it. X is increasing by 1 and y is increasing by 4. No change at any point. So they are directly proportional. Now it says if it was inverse, x was 3, 4, 5, 6, then what would be y? 12 is given. So if it was inverse, see indirect, we were dividing, and in inverse, we will multiply. Y is inversely proportional to x. So y is equal to k over x. So what is k now? K is x into y. K is 36. I'm rewriting the equation. So y is equal to 36 over x. Now I just need to substitute x. 36 by 4 is 9. 36 by 5, 36 divided by 5 is 7.2. And 36 by 6 is 6. If this was inverse, we will get these values. Any doubt till now?
So, when it's inverse, we just solve it through inverse by plugging in the values, and then we can plug in the table values, and then
Yes.
we can get the values. Okay.
This equation form is the easiest one and no confusion at all. We don't have to think about anything. We just go for k and write the equation, substitute the missing values, and we always end up with the correct table.
Okay.
Worked example. Speed of water in a river is determined by a water pressure gauge. The speed V meters per second is directly proportional to the square root. Directly proportional. What is directly proportional? Speed is directly proportional to square root of height. The speed is directly proportional to square root of height is using V. I'll write V. And when we fit in K, the sign of proportionality changes into equation. Now we'll always have one set of value, and it says when height is 36, the speed is 8. 8 is equals to K square root 36. Now we are working for K. Square root 36 is 6. So 8 divided by 6 is 4 by 3. K done. So I can rewrite the equation this one. So it is V is equals to 4 by 3 square root H. Now when H is equals to 18, calculate the value of V when H is 18. So we just substitute 4 by 3 into square root H. I'm getting 4 square root 2, which is 5.65, 5.66 around it. Any confusion?
No, we're just substituting the value, so no.
Yeah. Try the first one.
So y equals 4.5 over x for A.
We are writing the 4.5 over x. That's correct.
Okay.
There are two ways of writing decimal, or we just wrote 4.5 over x. We could also write 9 over 2x. Right?
Yes. Y equals 5 over 2x.
Y is equal to 5 over 2x. Yes.
Y equals 25 over 2x.
Correct. You must be getting the trend as well. Whenever they're inversely proportional, we are dividing them. So y is equal to 0.4 over 0.7 x. So y is equals to 4 over 7x. If we go in decimals, that would be 0.5714. So it's better we stay in fraction. And the last one, 0.6 by 8 is 3 by 40. So y is equals to 3 by 40x. Number 2, y is inversely proportional to x cube. Now in case of inverse, this is y is equals to k over x cube. If y is 80 and x is 4, the only mistake students make is they forget to take the cube. So 4 cube is 64 into 80 is 5120. So this is y is equal to 5120 over x cube. You have the equation, we can substitute. The first one says find the constant of proportionality, that is 5120. Value of y when x is 8.
So we multiplied 80 by 16 to get k.
Not 16, 64.
Sorry, 64. And then it was 5,120 over x cubed, right?
Yes.
Okay.
What is the value of y when x is 8?
Ten?
Correct. So y is 10. And when it is 6,
23.703, so just 23.7.
correct. The value of x when y is 24.
5.975, so 5.98.
Correct. Given that y is inversely proportional to x square, complete the table. Now having that practice, I'm just writing it for now that it would be yx square. If you have that, you can write it directly, but let's just don't do that to lose a mark. Y is inversely proportional to x square. So one set of values known, and y is 1, x is 0.5 squared. So 0.5 squared is 1 by 4 or 0.25. So I'm writing y is equals to 1 by 4x square. And we have all the values of x. We have the equation and values of y, and we can substitute. So I'm substituting 0.1 in the equation, and I'm getting 25 for the first one. Then 0.25 I'm getting 4. Then I have the value of y. I need to find x. I'm getting 1 by 256. Are we getting same answers? And this one minus 3, 0.0039.
Yeah, 0.00396. So this is 0.003 or 0.004.
Yes, we can write that 0.004. If the examiner is expecting like the answer to one significant figure, then yes. If 3, then 391. Try question number 4.
I got 0.25. I'm going to try doing it again.
With 100?
Yes.
Okay, I'll also quickly check it. I'm getting 5 again.
So basically what I did first was that I did the equation from like 25 and 10,
Yep,
and then I got y equals 50 over square root x.
correct.
And then afterwards I plugged in the y and I just plugged in the y. So 100 equals to 50 over square root x.
That is x, not y. 100 is
Oh, okay, I see. So I have to do square root 100 basically. Okay.
getting same answers.
I'm trying the next one.
Okay.
Okay, the rest is correct.
Okay. X and Y are known to be proportional to each other. When X is 20, Y is 50. Find K if. So let's do that. I'll write my values.
Same values.
Number 6. So you've understood the theme. Now it's just practice. A is directly proportional to R square, where R is equals to 3 and A is equal to 36. Find the value of A when R is 10. Now see, the examiner is not telling you to find the equation or K or anything. Now you know how to handle the question. So it says it is directly proportional to R, so I would write Y, A, that was A, not Y. I would write A is equal to KR square. Now we have first set of value R3 and that 36. So 36 is equals to K into 3 square. 3 square is 9. Dividing on the other side, K is equal to 4. So my equation is Y is equal to 4R square. Once done, find the value of A when R is 10. So 4 into 10 square. 10 square is 100 into 4. 400. Try 7th.
0.1.
7th?
6.4.
I'm getting 2.4.
Okay, I'll try again.
That is D cube.
Sorry?
D cube. Did you take the cube?
Yes, I did. I'm just gonna try again. Maybe I like pressed something wrong.
I'm getting K as 800. What's your K?
For the first equation, I got K as 12.5.
No, in question number 7.
Yes.
K is 800. This is inversely proportional.
Yes.
We
So
actually did 100 divided by 8. That was 100 multiplied with 8.
yeah, so I got K over D cubed. And then
Yeah.
I plugged in the D with this 2. So L equals K over 8.
So that's a product, not division.
Yes.
So you'll get K as 800, not 12.5.
Oh, I think yeah, did I divide it? Because I got 12.5.
Yeah, you should multiply because this was inverse relation.
So 800 equals to K. And
Yes.
then we would plug it in. So it would be 800 times 5. No, 800 divided by 125.
Yes.
So that'd be 6.4.
Correct. Some corresponding values of P and Q are given in the table. Are P and Q inversely proportional? Justify your answer. So at the first glance, I see that Q is increasing and P is decreasing, but I need to justify. So how can we justify? Is we should get same K in all cases. So just tell me if this is true or false. Check through calculation and give your statement. Checking that.
Yes. Well, it's because that the top values, they're increasing in bottom values. So the independent values are increasing and the dependent values are decreasing.
Yes.
So one value is increasing, one value is decreasing. That makes it inversely proportional. So Q is increasing by 3 and P is increasing by not an something like an constant value. So 75 to 30, 45, and then 30 to 20, 10, and then 20 to 15, 5.
If you're looking at 2 and 5, the gap is 3. 3 and 8, the gap 5 and 8, the gap is 3. 3 and 12,
Yeah.
the gap is changing. So always easy to check it through the equation. The claim was that they are inversely proportional. So if the claim is inversely proportional, I can write Q is equal to K over P. Would you agree?
Yes, because
Then
it's reverse.
it should be the product of Q and P. So product of 2 and 75 is 150. 5 and 30 is 150. 8 and 20 is 160. It fails. And 12 and 15 is 180. It again fails. If it would have been inversely proportional, the product would have been constant. That means K would have been constant. So it is a no. This is not inversely proportional. It says justify your answer. So we tell them that the product is not constant. K is not constant.
So if it was constant, then it would be
Then
inversely
it would be
proportional?
yes. Yes.
Okay.
Question number 9. An electric current flows through the resistance R I current is inversely proportional to resistance R, and when resistance is 3, current is 5. Find the value of current when R is 0.25. Inversely proportional given, first set of value given. I'm getting 60. Current 60.
You're getting what? 16? 60?
60. 60. 60.
Yeah.
Same answer?
No, I'm just seeing again.
Okay.
Yep, 60.
Number 10. Corresponding values of S and T are given in the table. Which of the following statement is true? So directly or squared or cubed. So we check it in the same manner as we did in question number 8. So I'm just going for this first attempt. When I look at this, that T is directly proportional to S. So my K would be T over S. Yes or no?
Yes.
So I'm going to check that. Zero point 0.4 by 2 is zero point 0.2. 10.8 by 6 is 1.8. So I don't need to check the third one. It fails. K should be same for all. So it fails. So it is not true.
For the next one is T over S squared.
The K is T over S squared. So I'm checking for zero point 0.4 divided by 2 squared is 0.1.
Next one is 0.3, so no.
So no.
So
And
C would be correct.
T over S cube. So zero point 0.4 over 2 cube is 1 by 20. And 10.6 over 6 cube. Wait, this is again changing.
So
Did
none
you
of
get, are you getting the same?
so none of it is true. So 0.4. Let me
I'm
see.
quickly rechecking it. 0.4 by 2 is 1 by 5. T divided by S and T divided by S square. So T over S should be constant, T over S square should be constant, and T over S cube should be constant. So zero point 0.2 by zero point 0.4 by 2 is 1 by 5. 1 by 5. 10.8 by 6 is 9 by 5. So first one is a no. Now squared. Zero point 0.4 divided by 2 square is 1 by 10. 10.8 divided by 6 square is 3 by 10. So this is also a no. And the third one is cube. So zero point 0.4 divided by 2 cube is 1 by 20. And then 10.8 divided by 6 cube is 1 by 20. And then 50 divided by 10 cube is 1 by 20. So last one is true. Any confusion?
No.
Okay. Okay, we'll continue after your break from here and probably start new chapter as well. The
Okay.
shared link is at 12:30. It takes 4 people 10 hours to plaster a section of a building. How long will it take 8 people to do the same job, working at the same rate? Number of people and hours. So this question is pretty easy as the changing numbers are in proportion. 4 people, 10 hours. The people are doubled, so hours would obviously be halved. People, hours, 4 and 10, 8 and unknown. So 4 into 10 is equal to 8 into x. 40 by 8 is x, and x is equals to 5 days, 5 hours. Number 12. An industrial experiment is In an industrial experiment, it is found that the force F needed to break a concrete beam varies inversely with the length of the beam. If it is more in length, that would be easier to break. If it takes 50,000 newtons to break a concrete beam 2 meter long, how many newton will it take to break the beam that is 6 meter long? Again, it is inversely proportional. We multiply them straight. So this is 2 into 50, 100,000, 100,000 by 6. Newtons. Any doubt?
No.
Try number 13.
A equals to 2. 2 Celsius.
Correct.
B is negative 24.
Distance cannot be negative.
24.
No. C. This is 6 degrees and 4 kilometer. Now that was 20. We found that at 12 kilometers and x. And we found that x is 2. Now see, in 8 kilometers, the temperature dropped by 2. Right?
Yes.
8 kilometers gives you a drop of 2 degrees Celsius. That means 4 kilometers gives a drop of 1 degree Celsius. And we already had 6 degrees Celsius at 4 kilometers. And when I'm talking about -1, this is a drop of 7. So 7 4 times is 28. It would be 28 kilometers below.
So wait, so it's 6 degrees Celsius and then we subtracted by 28 degrees.
No, 28 kilometers. I'll say that again. It was 6 degrees Celsius at a depth of 4 kilometers. Then you found out that at a depth of 12, the temperature will be x, which is 2 degrees Celsius. So we see that when there is change of 8 kilometers depth, there is change of, sorry, it dropped by 4. I used 2. This was 2. So in 8 kilometers, the drop was 4. So every 2 kilometers, there is a drop of 1. Every 2 kilometers, there's a drop of 1. Now from 6 to -1, this is 7 degrees. 1 degree shows a drop of 2. So this is 7 degree change. So it should drop by 14 kilometers. So 4 and 14 is 18 kilometers. It should be at 18 kilometers below when the temperature is -1.
So how did we get 7 again?
6 and -1, the difference is 7.
Okay, yes. So -6 minus -1.
Positive 6 and -1.
Oh, yes. So we're subtracting them. So it's 7. And then, so the needs to go down by 7
Yes.
for the 4 as well, the 4 kilometers.
I'll draw the table as well to avoid these confusions. Let's say this is sea level, 0 kilometer, but the temperature is unknown. And we know at a depth of
4 kilometers.
yeah, 4 kilometers depth, temperature is 6 degrees Celsius. Then we found out that at 12 kilometers depth, the temperature was 2. Okay.
Yes.
And now the question is, where will it be for -1? And I saw that this is a change of 4 degrees Celsius, a drop of 4 in a change of 8 kilometers. That would just mean that drop of 8 means drop of 4. That shows 1, 2, 3, 4. That every 1 degree Celsius dropped by 2 kilometers. Right? So if
Yes.
I just count it manually, another drop of 1 degree Celsius, then another drop of 1, then another drop of 1. This is 2, and add to 14, add another to 16, add another to 18. So 18 would be final answer. But how I calculated with 7, using 7. This was my main given value, and I'm using this with the new question. And I can see that from 6 to -1, the change in temperature is 7. And we can see that with 1 degree change, the drop was 2 kilometer. So by 7 degree change, the drop will be 14 kilometer, like 2 kilometers every degree. Is this 14 understandable?
Yes, because it's 1 degree Celsius would have to be multiplying that, so it's going to be 14.
Yeah. Now it is dropping from this point. So 4 is already there and 14, so that gives us 18 kilometers. So it should be 18 kilometers below sea level to show a temperature of -1.
Okay.
Variable P varies directly as variable M and inversely as variable N. If P is 24 when M is 3 and N is 2. Find P when M is 5 and N is 8. Okay. Now see that we've been doing this for K, that when they were directly proportional, P is directly proportional to Q. So we were writing this, and K is constant. So I can say the first value of P and Q is equal to this relation of second value. And same goes with this relation of third value. And in case of inversely proportional, the product is same. So first value is equal to product of second value is equal to product of third value. Any doubts? In case of directly proportional, the division should give the constant value. In case of inversely proportional, the product should give,
Multiplying it. So it would be P1 and then Q1 and then P2 and then Q2.
yes. So in this case, variable P varies directly as M. That means we are going to divide them. And inversely as N, so that's a product.
But why is it P1 and then Q1 and then P2 and then Q2? Why is there 2 and then the 1?
This 1, 2, and 3 is just first value, second value, third value. For example, you have this table, and this is P and this is Q. So 1, 2, 3, 4. And let's say that was 8, 16, 24, and 32. And I'm saying they are directly proportional. So P is directly proportional to Q, and P is equal to KQ. So P over Q would be K in case of direct. So see, 1 by 8, 2 by 16, 3 by 24, 4 by 32, all are same. So I'm saying that this is 1, first value, or this is 2, second value. So if I just number them, P1 over Q1 equals P2 over Q2, just to see. So I'm writing 1 over 8 is equal to 2 by 16. Is it yes or no? Or I add the third set, 3 by 24.
Yes. It does equal.
So in case of direct, we divide. In case of inverse, we multiply. So P weighs directly as M, so we divide. And inversely as N, so we multiply. So P over N multiplied by N. Now, if I just ignore 1, 1 and 2, 2, I can just write them as equal. One thing. Now, if I'm going to plug in the first value of N, P, that would be first value of N and first value of M. If I plug in second value of P, that should be with second value of N and second value of M. So it says if P is 24, at the point when P is 24, M is 3 and N is 2. So what would be P when M is 5 and N is 8?
Wait, sorry. So how did we combine the two?
Just read it, that first three values and then the other three values. Variable P varies directly as M, so I'm dividing it because of this word directly. And then inversely as N, so
So
multiplying it.
okay.
P is 24 and M is 3 and N is 2. So simple substitution. Find P when M is 5 and N is 8. And then we simplify. So this is 24 into 2 over 3. 5 comes on this side. 8 comes on this side is P. So 8 3 is a 24 and 24 goes away. P is equals to 10. Any doubt?
So it's 24 times 2 over 3 because that's the first part, and then we have to multiply the 5 and then do like also the 8 as well, right?
Yes.
Because find P when M equals to 5 and N equals to 8. And then we just do it and it gets M equals to 10.
Yes.
Okay.
Increasing and decreasing amounts by a given ratio. Now that will be easy. Always we are just going to multiply with the given ratio. F is increasing. So we will multiply it with the ratio in this way. And when it is decreasing, we just write the lesser value at top. And in questions, that will be given in order as well. 11.5, that will be given as 511. So 7, if in worked example 17, you found that 11 bottles of perfume. So whatever that was, this is the new one. Given the cost of 5 bottles, this is an example of increasing an amount in a given ratio. You could have been asked to increase 200 in the ratio 11:5. So we just multiply it by 11/5. Numerator is more in case of increasing. In case of decreasing, numerator would be less. So when this number is more than 1, obviously it is increasing. 200 into 11 by 5 gives me 440. Decrease this in this ratio. So 45, when we are decreasing, numerator is less. And we get 30. Increase 40 in the ratio.
56.
40 into 7 by 5. Correct.
And then 2 is 24. And then 3 is 105.
32 into 3 by 4. 24 is correct. 105 is correct.
And the next one is 38.
Is 38 correct? Nick has a picture of his dog that is 16 centimeters long and 18 centimeters wide. If he enlarges the picture in the ratio 5:2, what are the new dimensions? 16, 10. Then we enlarge
So
5:2.
40 by 25.
40 by 25. Correct. Okay. Let's start a new chapter.